We are live.
Unmute Medini and Pramarth.
Unmute all this.
And let's start. Let's start.
Hi everyone, this is Pramarth. I, along with Nandini, will be your host for the first session today. Welcome everybody to Vividha Curious Minds. Hi, Nandini.
Hello Pramatana. Hello all. Curious Minds is a program to encourage science and math learning among children with special needs. This is the 5th year of celebration of curiosity. This program is hosted by Vividha, a Bengaluru-based organization working towards inclusion and education of children with special needs.
How many children are joining this time?
There are 37 participants and they are from many organizations like Rangaram Memorial School for Differently Abled, NAB Delhi, Sri Sharada Devi Andhara Vikasa Kendra, Chakshumati, Karnavidya Foundation, Golden Arch Montessori School. Welcome to all of you for the day 1 of the event.
How the program is conducted, Nandini?
This program is conducted on Zoom and live streamed on YouTube. If you have a question for the participant, use Zoom option raise hand. For those on YouTube, questions can be posted in the chat section of YouTube. We will answer as soon as time permits. The videos are in many languages. We have tried to make them accessible as much as possible.
It's been a party.
Are you serious? What do you have for us? I'm curious now.
Tell me what is a party?
Some music? Balloons?
Double ready.
Popcorns and some entertainment?
Ready. Our iron is so good with music. Anything you give, you produce music. And Varshini is trying to tie the balloons and found something very interesting. We'll see that.
What's a party? Without a party popper? Hema will show us how to make a party popper. And Satvik is making some popcorns and observing something very interesting. And some entertainment. How about some shadow play?
I'm eager to watch the movie. We'll start.
I am Coco Bucks. Papa.
Okay. Hema, you are going to make popper.
Papa.
Okay. What are the things you need to make this popper?
Papa. Ibiti Tati roll.
Okay. You need an empty tissue roll. Okay.
Bottle.
Balloon.
Tam.
Tape.
Tippy. Papa.
Paper.
Tata.
Okay. And scissors.
Let's start.
Okay. Let's start. First, what are you going to do?
go to put a knot
Okay, you're
on
going to
the bottle.
put a knot. Okay, show to the video. Okay, putting a knot. Okay, then
Then I cut the other side.
okay, you cut the other
Cut.
side of the balloon. Okay, the next step.
Was the bottle to the that's roll.
Okay, you are going to fix that balloon to the empty tissue roll. Okay. Okay, then
Suck them.
okay,
Okay.
stick a tape. Okay. Okay, you are sticking this tape over the balloon. Okay. So it stick properly. Okay. Yes. Then next step.
And then
Next step.
cut. Papa.
Okay.
Papa. To cut.
Okay, you are cutting paper into small pieces. Okay, then
But Papa. And you do the roll.
okay, now you are going to put this small pieces of paper into the tissue roll. Okay. Okay.
What. Papa. Ready.
Okay.
Pull.
Okay, your paper is ready, right? Yeah. Pull the balloon. Yes. Okay, again. Yes. Wow, nice. Yes. Hema, did you understand what is the science behind this?
Pull to cut.
Energy. Okay. Balloon is pulled to get more energy. Okay.
Pull push
Okay.
this push the papa out.
Okay. So when we pull and leave the balloon, so there is a force. Okay. This force push the paper out. Yes. Very good. Very good.
Hello everyone. As a part of daily activities, we give Aryan many things, of which he always try to produce music. అది ఎలా? ఇంకా ఏం చేసావు ఫ్లూట్లోంచి సౌండ్ రావాలంటే? వాట్ డిడ్ యూ డూ? ఎయిర్ ఎలా? ఉఫ్ఫను బ్రీజ్ ఇవ్వు. అలా ఫ్లూట్లో ఉఫ్ఫను ఎలా వస్తుంది? ఏం టచ్ చేస్తే వస్తుంది టంగ్ అని? ఏం టచ్ చేస్తే టంగ్ వస్తుంది? ఏంటవి? స్ట్రింగ్స్. ఏవి స్ట్రింగ్స్ చూపి? ఏం టచ్ చేస్తే? ఎలా ప్రొడ్యూస్ అవుతుంది?
ఏంటది?
ఎలా చేసావు? ఎలా వచ్చింది సౌండ్? ఎలా వచ్చింది? ఏంటది? ఫస్ట్ ఏంటిది? వాట్ ఇస్ దిస్? ఏంటది? ఓకే, మౌత్ ఆర్గన్లో సౌండ్ ఎలా వచ్చింది?
Aryan is trying to imitate the music made from his toy on his keyboard.
Quiz time. Let's check whether Aryan is able to relate to the sound I play to the ones he explored. Veena. Very good. It is Veena. Violin. Correct. Violin. Violin ఇంకొకటి కూడా ఏదో వినిపిస్తుంది. ఏంటది? Violin correct. ఇంకొకటి ఏంటి? It's a tabla. Violin and tabla. ఇదే మ్యూజిక్ ఇన్స్ట్రుమెంట్ చెప్పు. తబలా కాదే. తబలా లాంటిది. ఇట్ ఈస్ లైక్ తబలా కానీ వేరేది. వేరే తబలా. చెప్పేది. ఇట్ ఈస్ మృదంగం. చెప్పు. మృదంగం. ఏంటది? మ్యూజిక్ వచ్చి పాట్ తెలుసు కదా నీకు? మడ్ పాట్, క్లే పాట్, కుండ. కుండ మీద టక్ 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 అని చేస్తున్నారు. టప్ప టప్ప అని ఎలా వచ్చింది? కుండ మీద. కుండని ఏం చేసావు? ఉఫ్ఫని ఊదితే వచ్చిందా? లేకుంటే స్ప్రింగ్ పుల్ చేసావా? లేకుంటే అని చేసావా? టప్ టప్ అని చేసావా? టప్ అని చేసావా? వెరీ గుడ్. ఏం ఇన్స్ట్రుమెంట్? ఫ్లూట్ కాదే, లైక్ ఫ్లూట్. సౌండ్ ఎలా వచ్చింది అనిపిస్తుంది నీకు? పూజ. కరెక్ట్. ఏం ఇన్స్ట్రుమెంట్ అంటే ఇట్ ఈస్ అ ట్రంపెట్. చెప్పు. ట్రంపెట్. కాదు, వీణ కాదు, ఇంకొకటి ఏంటో. లైక్ వీణ. యా, ఇట్ ఈస్ లైక్ వీణ. ఇట్ ఈస్ మ్యాండలిన్. ఏమంటుంది? ఏమనింది? నువ్వు చెప్పు. ఎలా అనింది మ్యాండలిన్?
1 2 3 4 5
Satvik is busy counting something.
45 46 40 47 48 49 50 50.
Okay. Satvik, how much is the quantity now?
With bowl is half.
Now what will do with this corn, Satvik?
We will make popcorn, Mama. Mama, ಏನೇನೋ ಟಕ್ ಟಕ್ ಅಂತ ಬರತೈತೆ. ಪಪ್ಪಾಗತೈತೆ ಅದು ಪಾಪ್ಕಾರ್ನ್. These are popcorns.
Okay. Now can you count and fill in the same bowl?
Okay. 1, 2, 3, 4, 5, 12, 13, 14, 15, 16, 17, 18. Is full, Mama. It is not filling. Popcorns is very big.
See what is there on the table.
This is a cotton.
Okay. Cotton cover.
It is an empty box.
Cotton cover and the box. Which one is big?
Cotton. Big.
Okay. So can you fit this cotton in this box?
I can't fit, Mama.
Let us try.
Okay.
Stuff and stuff. Satvik and his mother are stuffing the cotton in the box. Finally, all the cotton is fit into the box.
Very nice.
Thank you, Mama.
So what are there in the tray, Satvik?
These are balloons.
Okay. Can you count how many balloons are there?
Okay. 5 balloons.
Can you hold all the balloons in your hand?
Yes.
Can you blow this balloon?
Okay. I can try.
It is not possible. Let me help you.
And balloon has big.
So can you hold this balloon in your hand?
Yes.
Okay. If I give you more balloons, can you hold?
No.
Check. See, 2 balloons are there. Can you hold in one hand?
No.
The blown balloons are flying away from Satvik's hands.
Why you can hold empty balloons? Why not this one, blown balloons?
It is a very big.
ನಿನ್ನೆ ಕಟ್ಲಿ ನೆನಾಕಿದ್ವಲ್ವಾ? ಈಗ ನೋಡು ಹೆಂಗಾಗಿದೆ ಈಗ.
ಈಗ ನೀರು ಏನೋ ಆಗ್ಬಿಟ್ಟದ ಮಮ್ಮ.
ನೀರ್ ಏನಾಗಿದೆಯಾ? ಓಕೆ.
ಅದು
ಅಲ್ಲ ಕಡ್ಲಿ ಈಗ ನೋಡು ನಿನ್ನೆ ಹೆಂಗಿದ್ದು ಕಡ್ಲಿ?
ಸ್ಮಾಲ್ ಇದು ಹಾರ್ಡ್ ಇತ್ತು.
ಈಗ
ದೊಡ್ಡದಾಗಿದ್ದಾವೆ.
ಹೌದಾ? ಓಕೆ. ಆಮೇಲೆ
ಸಾಫ್ಟ್ ಆಗಿದೆ.
ಹೌದಾ? ಸೊ ಇದು ನೀರು ನಿನ್ನೆ ಎಷ್ಟು ತಗೊಂಡಿದ್ವಿ ಹೇಳು?
1 ಗ್ಲಾಸ್.
ಸೊ ಈಗ ಇದನ್ನ ನೀರನ್ನ ಸೋಸ್ಬಿಡೋಣ.
ಹಾಂ.
ಓಕೆ. ಈಗ ನೋಡು ನಾವು ನೀರೆಲ್ಲ ನಿನ್ನೆ 1 ಗ್ಲಾಸ್ ತಗೊಂಡಿದ್ವಿ. ಈಗ ನೀರು ಎಷ್ಟಿದೆ?
ಹಾಫ್.
ಹಾಂ. ಸೊ ನಿನ್ನೆ ಫುಲ್ ಇತ್ತು, ಈಗ ಹಾಫ್ ಆಗ್ಬಿಟ್ಟಿದೆ. ಎಲ್ಲೊತ್ತು ನೀರು ಗೊತ್ತಾ?
Satvik is now exploring the chenna that he soaked yesterday using 1 glass of water. The chenna has become big and also soft. After draining the water from the soaked chenna, he could only get half the glass of water, but he had used 1 full glass. Where did the other half glass of water go?
Hello friends, my name is Vignesh and I am in grade 3. Hope you all are doing good. Our world is full of amazing things. and lot of things goes around us every day. One afternoon, it was pretty sunny outside, and I was just sitting under a tree very peacefully. I started wondering about the shadow that tree was providing. How cool is the shadow? This made me to think about shadow. What is shadow? How it is formed? I will demonstrate behavior of shadow which we see daily. Early in the morning when sun rises and sun falls on me, it creates large image. During noon when sun is overhead, I don't see shadow. Again during evening, the shadows grows larger on opposite side. A shadow is a dark area formed where light from a light source is blocked by an object. Shadows are formed because light travels in straight lines, and whenever an object is placed in path, light's rays are blocked. The light rays that go past the edges of the object makes outline for the shadow. Shadows are formed by either natural or artificial source of light. Sun is natural source of light, whereas bulbs, candles, torch are artificial. Let me show you some beautiful shadow art. Hope you like it.
Vignesh is displaying the shadow of a flying bird using his palms. He is displaying the shadow of a hood of a snake with his curved palm. Now he is displaying the shadow of a cat with folded thumb and middle finger. In this image, Vignesh is displaying the image of a barking dog by showing his palm with an open little finger. In the next image, Vignesh is displaying the shadow of a deer by touching his thumb, middle and ring finger together.
ನಮಸ್ತೆ, ನನ್ನ ಹೆಸರು ವರ್ಷಿಣಿ. ನಾನು 7ನೇ ತರಗತಿಲಿ ರಂಗರಾವ್ ಸ್ಮಾರಕ ವಿಕಲಚೇತನರ ಶಾಲೆ ಮೈಸೂರಿನಲ್ಲಿ ಓದ್ತಾ ಇದ್ದೀನಿ. ನಾನು ಇವಾಗ ಉಷ್ಣದಿಂದ ಗಾಳಿಯ ವಿಕಸನ ಹೇಗೆ ಆಗುತ್ತದೆ ಎಂಬುದನ್ನು ಒಂದು ಪ್ರಯೋಗದ ಮುಖಾಂತರ ಪ್ರಸ್ತುತಿಪಡಿಸುತ್ತಿದ್ದೇನೆ. ಮೊದಲಿಗೆ ಈ ಪ್ರಯೋಗವನ್ನು ಮಾಡಲು ಬೇಕಾಗಿರುವ ಸಾಮಗ್ರಿಗಳು: ಒಂದು ಬಾಟಲ್, ಒಂದು ಬಲೂನ್, ಬಾಟಲ್ನ ಬಾಯಿಗೆ ಬಲೂನ್ ಅನ್ನು ಸೇರಿಸಿದ್ದೇನೆ. 2 ಪಾತ್ರೆಗಳನ್ನು ತೆಗೆದುಕೊಂಡಿದ್ದೇನೆ. ಒಂದು ಪಾತ್ರೆಯಲ್ಲಿ ತಣ್ಣೀರು, ಮತ್ತೊಂದು ಪಾತ್ರೆಯಲ್ಲಿ ಬಿಸಿ ನೀರನ್ನು ತೆಗೆದುಕೊಂಡಿದ್ದೇನೆ.
Varshini is presenting an experiment to show how air gets expanded when heated. Material required are a plastic bottle, a balloon, 2 vessels, one containing hot water and the other cold water. The balloon has been fixed to the mouth of the bottle.
ಮೊದಲಿಗೆ ಬಲೂನ್ ಅನ್ನು ಸೇರಿಸಿರುವಂತಹ ಬಾಟಲ್ ಅನ್ನು ಬಿಸಿ ನೀರಿನ ಪಾತ್ರೆಯೊಳಗೆ ಹಾಕ್ತಾ ಇದ್ದೀನಿ. ಈಗ ಬಲೂನು ಹಿಗ್ಗಿದೆ.
At first, she places the bottle fixed with the balloon in hot water. The balloon is getting bigger.
ಅದೇ ಬಾಟಲ್ ಅನ್ನು ತೆಗೆದುಕೊಂಡು ತಣ್ಣೀರಿನ ಪಾತ್ರೆಯೊಳಗೆ ಹಾಕ್ತಾ ಇದ್ದೀನಿ. ಈಗ ಬಲೂನು ಕುಗ್ತು.
Varshini is now placing the same bottle with the blown up balloon in cold water. The balloon deflates.
ಇದಕ್ಕೆ ಕಾರಣವೇನೆಂದರೆ ಬಾಟಲ್ ಅನ್ನು ಬಿಸಿ ನೀರಿನ ಪಾತ್ರೆಯೊಳಗೆ ಹಾಕಿದಾಗ ಬಲೂನು ಹಿಗ್ಗಿತು. ಏಕೆಂದರೆ ಉಷ್ಣದಿಂದ ಗಾಳಿಯು ಬಿಸಿಯಾಗಿ ಜಾಸ್ತಿ ಜಾಗವನ್ನು ಆಕ್ರಮಿಸಿಕೊಳ್ಳುವುದಕ್ಕೋಸ್ಕರ ಅದು ಬಲೂನ್ನ ಒಳಗೆ ಹೋಗಿ ಬಲೂನು ಹಿಗ್ಗಿತು. ಅದೇ ಬಾಟಲ್ ಅನ್ನು ನಾವು ತಣ್ಣೀರಿನಲ್ಲಿ ಹಾಕಿದಾಗ ಬಲೂನು ಕುಗ್ಗಿತು, ಏಕೆಂದರೆ ಬಲೂನ್ನಲ್ಲಿರುವಂತಹ ಗಾಳಿಯು ತಂಪಾಗಿ ಮತ್ತೆ ಬಾಟಲ್ನ ಒಳಗೆ ಬಂದಿತು. ಹಾಗಾಗಿ ಬಲೂನು ಕುಗ್ಗಿತು. ಈ ಪ್ರಯೋಗದಿಂದ ನಾವೇನ್ ತಿಳ್ಕೊಬಹುದು ಅಂತಂದ್ರೆ, ಉಷ್ಣದಿಂದ ಗಾಳಿಯು ವಿಕಸನವಾಗುತ್ತದೆ. ಧನ್ಯವಾದಗಳು.
Varshini explains, when the bottle is placed in hot water, the air in the bottle expands due to the heat, and then the air enters into the balloon, thereby making the balloon bigger. When she places this bottle in cold water, the air in the bottle compresses and the balloon deflates. This experiment shows that when air is heated, it expands.
Wow, that was fun.
Yes, there are few more fun experiments with air pressure. Tell me what happens when you blow air between two balloons.
We tear apart what else?
Duptaka will show us what happens. And Giri is showing a cool trick with egg.
And Varshini is she is showing us a ghost in a glass drinks water from the plate.
Ghost? I'm scared. But can't wait to watch. Let's begin.
Hi friends, my name is Yukta. I am studying 6th standard in Sri Sharda Devi under Vikas Kendra School. Today I am doing one science experiment called air pressure. For this experiment, materials required are 2 balloons, thread and a flat stick. Then we need to fill the air in the balloons and tie the balloons with the thread and hang it to the stick with 10 centimeter gap. After this, we should hold stick upside. Now I will blow the air between the 2 balloons. Let's see what happens. Wow! The 2 balloons meeting together. This is the reason when I blow the air between the 2 balloons, the pressure of air decreases. Balloons come closer to each other. Thank you.
குட் மார்னிங். நான் பிகிரி. நான் 5th ஸ்டாண்டர்ட் A செக்ஷன் படிக்கிறேன். நான் இன்னைக்கு என்ன பண்ண போறேன்னா எக்ஸ்பெரிமெண்ட் பண்ண போறேன். அதோட நேம் எக் இன் பாட்டில். இப்போ நான் ஏர் பிரஷரை பத்தி சொல்ல போறேன். இந்த எக்ஸ்பெரிமெண்ட் பாட்டில், பாயில்ட் எக் அண்ட் பேப்பர் தேவைப்படுது. முதல்ல நான் ஒரு பாட்டில் எடுத்துக்கிறேன். அப்புறம் பாயில் பண்ண எக் எடுத்து இந்த பாட்டிலோட நெக்ல வைக்கிறேன். ஸோ பார்த்தீங்கன்னா உள்ள போல. அதனால நான் இது ஏன் உள்ள போலன்னா, வெளியே இருக்க ஐ ப்ரெஷரும் உள்ள இருக்க ஐ ப்ரெஷரும் ஏர் ப்ரெஷரும் ஈக்குவலா இருக்கிறதால உள்ள போல. ஸோ அதனால நான் ஒரு பேப்பரை பர்ன் பண்ணி உள்ள போட்டுக்கிறேன். ஏன்னா ப்ரெஷர் ப்ரெஷர் அதிகமாகும் பாட்டிலுக்குள்ள. ஏன் ப்ரெஷர் அதிகமாகுதுன்னா டெம்பரேச்சர் அதிகமாகிறதால. டெம்பரேச்சர் வந்து ரொம்ப ஹாட்டாகவும் அதனால ப்ரெஷர் அதிகமாகும். இப்போ நான் வந்து பேப்பரை பர்ன் பண்ணி உள்ள போட்டுக்கிறேன். ஸோ இப்போ நான் வந்து முட்டியை அதுக்குள்ள வைக்கிறேன். ஸோ பார்த்தீங்கன்னா உள்ள போயிடுச்சு. இது ஏன் உள்ள போச்சுன்னா மேலே வந்து ஏர் ப்ரெஷர் வந்து அதிகமாக இருக்கிறதால இந்த முட்டையை வந்து உள்ள தள்ளுது. ஸோ அதனால வந்து முட்டை வந்து உள்ள போயிருது. The pressure outside is higher compared to this bottle. Compare the pressure inside the bottle. Thank you.
Myself Ayushi, studying in class 10th and lives in National Association for the Blind NAB, Delhi Arthipuram Sector 5. Today I am going to show an experiment to all in which we will know that why water level rises up when burning candle puts off. For this I will need a saucer, a candle, and a transparent glass whose height should be more than of candle, water and matchbox. For start the experiment, first of all I will pour this water inside the saucer. Now I will keep this candle inside the saucer and will burn it. I have burnt the candle. Now I will cover it with glass.
The candle has extinguished. The level of water has raised inside the glass.
As you can see, there is no much water is left in the saucer. Now I will pull off the glass. As you can see, when I have pulled off the glass, I need to exert more pressure because water have exerted pressure on the glass. Explanation: when a candle was covered with glass, the supply of oxygen cuts off and burning candle puts off, due to which the air pressure inside the glass decreases suddenly. But outside of the glass there was presence of air atmosphere. So to get the equilibrium of pressures, water level rises up. Thank you.
Fun experiment. Some of us read a lot as a hobby. There are these sex-inclusive groups that help develop such hobbies. Today, we would like to introduce 3 sex-inclusive groups. Over to you, Pranavanna.
Hi, good afternoon, good evening, and good morning to all of you if you're watching from different areas. Currently, it's the afternoon where I'm sitting. It's so great to be here. Just for some context, I'm Pranav, and I'm a 16-year-old student from Bangalore, India. I have been trained by Vividha for quite a long time, and I'd like to start by thanking them. Well, first of all, I'd like to thank Medini for that wonderful introduction. It was so sweet. Thank you so much. I'd also like to thank Vividha for giving us this opportunity. It's really colossal and it's very, very special to be here. In fact, it's by Vividha and from Vividha that it all started at Vidyadrishti for us, which is, as you guys might have guessed, the name of my organization. We started out from Vividha by actually joining in a creative writing class. I was there with a few friends and a certain Mr. Subramani Lakshmi, who was our mentor. One day, as we were just discussing normally, we were talking about how to arrange a system for the book of the month, which is something that we were planning to do, where we would take a book every month, read it, and just have certain discussions on it. And that day, basically, he was trying to get us to put votes into a WhatsApp group. And me being someone who loves tech, I said, why don't I just create a small web application or a website for people, for just our classmates to vote for the book of the month. And 2 hours later, Vidyadrishti was formed, as we thought we would take it to the public. So as you guys might have guessed, we have our main goals set on writing and writing inclusively, because we believe that writing is one of those fields where the only thing that matters is your ideas, your creativity, and the tools you have to put that creativity onto paper or in digital media. Now, those tools can be honed by us. We can help you hone them. And that's basically what we try to do. Over the sort of 1 year, 1.5 year that we've sort of done our work, we have conducted multiple events, which we will talk about shortly. And we've also conducted quite a few sort of competitions and all that. We've also built a platform where you can write and you can write fearlessly. So if he's present today, I'd like to call upon Moksh, the head of our HR team and marketing and part of content, to actually talk a bit about why Vidyadrishti and what do we sort of believe in. Over to you if he's currently here. All right. I think he has had some problems. He did inform me he was having some glitches. So I'll take over for him. Okay, he's here. Anyway, so passing it over to Moksh, we're so sorry for this glitch. Passing it over to Moksh to talk about why Vidyadrishti and what we sort of believe in. Over to you, Moksh. Hosts may have to unmute him.
Moksh, you can unmute and talk.
Okay, I guess he's having some technical glitch. So I'll take over. Oops. Sorry, apologies for the delays. So basically.
Oh, hello. Am I audible now?
Oh, here he is. Okay, this has been very interesting.
Yeah, I was not
Yes,
allowing me to unmute.
Okay.
Sorry for that.
Here he is. Go ahead, Moksh.
Yeah, am I audible clearly?
Yes.
Yeah, so it wasn't allowing me to unmute. Sorry for the delay. So, yeah, so essentially Vidyadrishti is a writing platform. It allows anyone to express themselves. And the USP of Vidyadrishti essentially is that it's really accessible. You don't have to go through the hassle of actually creating a blog like on websites like themedium.com. So that's one of Vidyadrishti's USPs. It's really easy to create an account and start writing. And you can do it almost within like a minute if you just log on to www.vidyadrishti.net. You can post an article immediately. So while it doesn't allow you to create like a blog of your own or say like a website of your own, like many other popular platforms do, what it does is it just allows you to write articles without the hassle of dealing with things like search engine optimization and other such things that you need. And it also helps you with things like marketing and promotion and things like that. So essentially, Vidyadrishti, what we believe at Vidyadrishti is just about helping people express themselves, because we believe that writing is a very important skill. And soon in the summer, I think we'll also be hosting a few courses catered around this, as we believe that even if you don't want to become a writer, writing is an important skill that everyone needs to cultivate in order to write emails or text messages or any other simple things like that. It's an integral part of your life. And so we at VD just hope to help everyone express themselves and write better.
Thank you so much, Moksh. That was really, really enlightening. One more factor, and in fact, this is a big one, is we believe in writing, as I said, being inclusive. Nothing matters more than your hunger to write, is what we say. Not your color, not your ethnicity, not your physical condition, not any other condition you've got, not your socioeconomic status or any other factor, just your creativity and your hunger to write. However, you need to be able to write better as well. And that's a skill that takes time to learn, and we are ready to help you learn. In fact, we've conducted quite a few events to help people learn how to write. And to talk a bit about these events, just a quick recap on them. Here's Shubhika. If you could please unmute yourself.
Pranav, can you name her, please?
Shubhika.
Hello, everyone. I'm Shubhika. I'll tell you much about me a little bit later on, but I'll be talking about the events that Vidyadrishti has done. So first up coming is our writers' talks and camp. We did this in 2021. It consisted of many well-known writers coming up and helping our audience to write or giving them speeches about how really writing is important to them, or how writing inspires them to become one individual. Another event was our write-a-thon. We did have two phases of this. One was last year as well, but as we couldn't gain much audience, we are trying to do it again in this month coming October. This event consists of essay writing contest, where you will be given more than 100 genres and you can write on anything. And after writing these essays on our website, we will be giving you constructive feedback, as well as we will be telling you how to write it better, so that obviously your writing skills become better and better every day. Lastly, we had other update events as well. Tata, if you like to elaborate on them.
Thank you so much, Shubhika. We also do like update events on technology. We had just an update, which was actually quite known for its weird ad that we did in June of that year, where we just basically teased with some new stuff on the site, and then we had what's changed and what's coming in March of last year, where we teased it a design change. So now I'd just like to introduce two people. I've introduced myself, and honestly, there are people who are more interesting than me, who've been part of our team. Unfortunately, our entire team could not make it today. But two very prominent people. The first one is Kavya, who's actually been part of Vidyadrishti, Vividha, for as long as I can remember. And she joined in Vidyadrishti almost more than a year back. Unmute, Kavya, and just tell us about your experience at VD, a bit about yourself, and what you do at the testing team.
Hello everyone. I'm Kavya, and I basically got into VD. Also, sorry if I'm missing any points because I was kind of distracted for a second there. But anyway, I got into VD right as it launched. I've been with them for like a year. And I basically got a call from Pranav, who I've known for a long time, and yeah, I was just told about this, asked whether I wanted to join, and I was thrilled because I've had for a while an interest in writing. I'm not a most serious writer, but I have had an interest, so I was happy with VD's concept from the starting, and I've joined, and I am really happy with how things have been. So basically what I do, my job is to test. I'm part of the testing team. My job is to test the website, try and report errors and other issues. Also, if there's a new feature coming out, and I'll have to test it to make sure there are no bugs. And yeah, the other thing is the other thing I really like about VD, which I'd like to just go into for a second, is the atmosphere. It's always very casual and light, which is one of the things I really like about VD. And yeah, sorry for the stuttering, but that's basically what I wanted to say.
Thank you so much, Kavya. That's okay. I stutter more than you do. Moving on, we have Shubhika back again, who leads content at VD. And she joined, her joining experience was quite interesting. Let's hear it from you, Shubhika. You may have to unmute her again.
Yeah, am I audible now?
Yeah.
Okay, I'm Shubhika. I joined VD about almost a year ago. Now, my intent of joining VD was simple. I want to make a change or help people write better, read better. Reading and writing has always been an exceptional part of my life because when I was a child, I wasn't really into reading or writing either. But as I grew up, I understood that it is a very important part of your self-expression, and it develops most of your identity, because writing, it really just helps another person know how you are, who you are, into a deeper level. So I wanted to help others as well to help this privilege, and I actually first applied to Vividha, and from there I got introduced to Vidyadrishti, and that is how I came to come into the content team. The content team is basically, it goes by the name. We try to create exemplary content that could be articles, poems, or essays, anything, so that our audiences or viewers could help read that and create an content piece of their own. And after they create that, it is a simple process. We help them, we give them constructive feedback, and it is almost the same as the write-along event, just it is a usual thing that goes on every day.
Thank you so much, Shubhika. In fact, I remember the call that we had went on for over an hour. Finally, though I know we've been stretching time, I'd like to call upon one person who just shows that our camps do actually help. Shiva Reddy, which is, according to my knowledge, also his name in the participants panel, to come and give up his intro.
Hello, am I audible?
Yes.
Yeah, it gives me immense pleasure to be in front of you all. I mean, virtually, I guess. And, I was really thrilled to experience various experiments, that have been demonstrated by various kids. And talking about Vidyadrishti, I mean, it just happened with a summer camp, that Pranav spoke. And I was interested to get into that, as the importance of writing has been emphasized by all my speakers. I mean, all my friends, who just spoke before. And it was a summer camp which was held by various authors who demonstrated various, who hosted various sessions on various topics, illustrated how we have to work on them. And I was really interested and inspired by that. And after those sessions are done, there was even a news report contest that was held, and then I took part in it. And I was the one who could my report could make it to the first. I mean, it was judged by Subramani sir, who happens to be the Deccan, who works for Deccan Herald, and he also helps, or has been in Vidyadrishti since the inception, and has been helping Pranav. And then I wanted to get into Vidyadrishti as I know I want, as writing, which creating a writing platform, with inclusive writing platform without any barriers, is something that inspired me. And as a person who always wanted to inspire people by through my writing articles or poems or whatever, and I felt that this platform of such kind will be really helpful. So that kind of interest, and inspired me, and whoever would like to get into Vidyadrishti will definitely have a wonderful experience, and they need not have any fear or worry about their writing, as their writing will be very well judged. It will be given a good feedback, constructive feedback will be given, and there is nothing like good writing or bad writing, because every writing conveys some message or the other. So yeah, that's how my journey has been.
Thank you so much, Shiva. Just for all of you, I did not rig him to say this. In fact, we did not construct scripts for anyone, just allowing them to say what they liked. That concludes our presentation. Apologies for some technical glitches at the beginning, but we're really thankful to be here, and we hope you all can start writing at Vidyadrishti today. You can do that at www.vidyadrishti.net, which I will be pasting shortly into the chat. And you can also join our core team by clicking on Work with Us there. Again, we love being inclusive. We are really thankful to be invited to such an inclusive program. And that concludes our presentation. I would like to, as an end to this presentation, invite Ayan over to continue the program.
Hello everybody, my name is Ayan. I'm studying in DPS 8th standard, and could I request you to unmute Gauri Didi and Neerav?
Sure, Ayan.
Yeah. Vividha, I'm going to talk about Vividha Reading Group. Vividha Reading Group is a diverse reading group that has 3 members, Neerav, Gauridi, and me, Ayan. We meet up once in a week to read and we read in different ways. Neerav, can you tell me how do you read?
I read through my laptop in my laptop through the soft copy of the book.
And what about you, Gauridi? Oh, she's currently not there. So Gauri Didi uses hard copy, printed, and she reads, and I read through Braille. This is how our group is diverse. It's lots of fun reading together. We read the same book taking turns. The problems that we usually face are technical, or we all start talking together. So that makes a clash. And other than that, it's hard to decide who goes first. But these all problems are really not that hard to solve. Neerav, do you remember any other problems than this?
Earlier, I couldn't mark the document where I had stopped. Now I have found out the way.
The benefits of this group. It has improved me in my spellings and vocabulary, and it enables me to read. And what about you, Neerav?
It has improved my listening skill and my reading speed.
And Gauridi, can you share your experience if you're there right now? I guess she's not able to connect. So she says that she conducts the whole session or the whole meeting. It's a new experience for her because she's first time working with us. And yeah, it's lots of fun learning and reading together. And that's all. Thank you.
Hello, this is Gauri. I volunteer in helping both Ayan and Neerav with their reading. I couldn't unmute earlier because I wasn't apparently allowed to, but I'll I'll say that I'm having a really good experience with both of them, and I also get to learn a lot, and I'm getting to read a new story as well in a group, so it's really fun.
Next is Sagarika and team.
Hello everyone. Today I'm going to introduce you all to the audio description group. So I'm Sagrika. I study in 9th grade.
I'm Puri. I'm a 10th grader.
I'm Tanisha and I study in 7th grade.
I'm Samika and I study in the 9th grade. There are a few people who couldn't join us today. They're Harsh, Priya, and Sebastian.
So what is audio description? Audio description, also known as visual description, is a form of narration used to provide information surrounding key visual elements in a TV film or a TV program or a film or a theatrical performance. It's also a means to inform the individuals who are blind or who have low vision.
So what is the importance of audio descriptions and what are we doing to help with it? So audio descriptions are extremely important when considering people who are visually impaired and them accessing videos. So what we're trying to do currently is add audio descriptions to a variety of videos ranging from educational videos to entertainment videos to videos about accessibility. And we're working to actively make those more accessible, starting with audio descriptions for people who are visually impaired.
Audio description is also an important accessibility resource for those who have blindness, as it allows these groups to fully experience movies, TV shows, and other videos, and it also helps them to communicate much more better.
So I benefited from this audio description group because it helped me understand things in more detail. For example, when we discussed about birds, I better understood the anatomy of the bird and how their beaks are shaped and used.
Our main aim here is to provide solutions and work together to help people with disabilities and people who are visually impaired.
Some of the benefits of this for people who are not visually impaired, as well as like people who are working towards it, is understanding like looking at videos in more detail and understanding like deeper aspects of the visual components, as well as understanding
So when I was young and I went to the movie theater with my parents, I would never understand what was going on the screen, and this made me really dislike movies. My parents had to literally drag me to the theater and buy me a big box of caramel popcorn to keep me silent. Then one day, I saw this show called Just Add Magic, where they would describe things like the sun rising, a crow flying, or somebody giving something to someone else. And this was a completely different experience for me. I also saw a Hindi movie called Dangal, which was audio described. This was organized by Enable India. This is the first time I had seen an audio described movie. So, audio description is when visual components which are on the screen are described. My group aims to spread awareness and audio describe a few videos. Some videos that we have done are educational and cooking videos.
All right, so we just finished the first session. So the forum is now open for Q&A with participants so far. Anyone has any questions? Questions or observations, comments, suggestions? Pramarth has a question.
Actually, no question, but I will ask one question. How to, uh, uh, I, yeah, how to unmute?
Okay, you don't have a question. You know how to unmute. Pramath, hold on. Sagarika, do you have any questions?
Yeah.
Oh, you do? Okay, go ahead.
So my first question is about the experiment about musical instruments, which was done by Aryan. I really liked the experiment, and my question is, what's your favorite song, and which instrument do you like to play it on?
Thank you, Sagarika. Thank you, Sagarika. Thank you, Sagarika. A instrument definition. What is your instrument? This is Sagarika. Thank you, Sagarika. Okay, okay. Which is your favorite instrument? Tabla, flute,
ఇన్స్ట్రుమెంట్ ఏది ఇష్టం? ఫ్లూట్ ఇష్టం.
గట్టిగా చెప్పు.
గట్టిగా.
I like Neelambari. I like. Okay. His favorite song is Neelambari. It seems in Telugu. And his favorite instrument is flute.
గట్టిగా చెప్పు.
I like flute. I like flute. I like flute.
Okay, thank you, Aryan. My next question is for Satvik. A very interesting experiment. But where did the other half of the water go?
Did the water go, Satvik?
What
You had soaked the chana,
What?
no, in the
water?
where did that half glass water went?
Water
Kannada
drank the ನೀರು ಅದು ಕುಡಿಯಿತು.
What drank that water?
ಏನ್ ಕುಡೀತು ಸಾತ್ವಿಕ್?
ಸಾರಿ ಮ್ಯಾಮ್.
ಪರವಾಗಿಲ್ಲ ಹೇಳು, ಏನ್ ಕುಡೀತು?
ಅದು ನೀರೇನ್ ಗೊತ್ತಾ, ಅದು ಕುಡಿದೋಯ್ತು.
ಕುಡೀತು?
ಯಾಕೆ ಕುಡಿ ಚೆನ್ನಾಗ್ ಕುಡೀತು.
ಕಾಬುಲ್ ಚೆನ್ನ.
ಮ್ಯಾಮ್
ಕಾಬುಲ್ ಚೆನ್ನ. ಕಾಬುಲ್ ಚೆನ್ನ ಸೋಕಾಗಿ ಅದ್ ನೀರ್
ಸೋಕಾಗಿ ಅದು ನೀರ್ ಕುಡಿದ್ ಬಿಟ್ಟಿದೆ.
Okay, thank you.
Thank you, Kavita ma'am.
Okay, Kano, see you.
Okay, so my next question is for Hemang. I really like your party popper, but do you know any other mechanism which uses the same science?
Hemang? Sagarika, could you repeat the question for Hemang?
Is there another object that uses the same mechanism?
Hemang, do you know any other toy just like popper? Anything else that is just like popper? Do you know?
Any other toy like this? Yes.
What is
What is that? Popper. Is popper right?
What do you remember?
Ma'am, he is saying popper only.
Oh, okay.
Find out.
Okay. Do you know, Sagarika?
Yeah, another object which uses the same thing is a piston.
Hemang, Sagarika says piston. Next, you have to explore that.
Yes, sir.
Piston. You have to find out.
Okay.
Okay.
Thank you.
So,
This is a question. Sagarika, hold on. Looks like you have a series of questions. Hold on. Vritti is raising hands.
My question is to Girish. That what was he doing in video? What was he doing in the video? I didn't understand. So Girish video.
Giri,
Yeah.
Savita, can you translate into Tamil?
Hi Giri, Ruthi, நீ என்ன எக்ஸ்பெரிமெண்ட் பண்ணேன்னு சொல்றேன்.
நான் வந்து ஏர் பிரஷரோட எக்ஸ்பெரிமெண்ட் பண்ணேன்.
So Vritti, Giri says he did an experiment on air pressure. Giri, என்ன பண்ணேன்னு சொல்ல முடியுமா?
சொல்றேன் மேம். முதல்ல நான் வந்து ஒரு பாட்டில் எடுத்துக்கிறேன், அப்புறம் அது மேல வந்து ஒரு பாயில் பண்ண எக்க வைக்கிறேன், அது உள்ள போல. சோ இது ஏன் உள்ள போலனா மேல இருக்க ஏர் பிரஷரும் பாட்டிலுக்குள்ள இருக்க ஏர் பிரஷரும் ஈக்குவலா இருக்கிறதால உள்ள போல. சோ அதனால
நான் டிரான்ஸ்லேட் பண்றேன் Giri. So Vritti, Giri says he took an empty bottle and then tried to put a boiled egg through the mouth of the bottle, but it did not go inside because the air pressure inside the bottle and outside the bottle is the same. Okay. Let's ask what he did after that. அப்புறம் என்ன பண்ண Giri? சொல்லு Giri.
சொல்லுங்க மேடம். அப்புறமேட்டு வந்து நான் பேப்பர் பர்ன் பண்ணி, மேடம் நான் பேசுறது புரியுதா?
புரியுது, சொல்லு ராஜா.
நான் வந்து ஒரு பேப்பரை பர்ன் பண்ணி உள்ள போட்டுக்கிறேன். இது ஏன் பர்ன் பண்ணி உள்ள போடுறேன்னா பிரஷர் பாட்டிலுக்குள்ள பிரஷர் அதிகமாகிறதால. பிரஷர் ஏன் அதிகமாகுதுன்னா டெம்பரேச்சர் அதிகமாகிறதால. டெம்பரேச்சர் வந்து உள்ள வந்து ரொம்ப ஹாட்டாவும் கூலாவும் இருக்கிறதால பிரஷர் அதிகமாகுது.
Okay. So what he does is he takes a paper, burns it and puts it inside the bottle. Why he is doing it is because of the temperature inside the bottle, it becomes hot and the pressure increases. Right, Giri?
Yes, madam.
Then continue. What happens after that?
அப்புறம் நான் வந்து முட்டைய வந்து இந்த பாட்டிலுக்குள்ள வைக்கிறேன். ஜாகில் அசிக்கும், அப்புறம் உள்ள போய்டும்.
So now he again tries to keep the boiled egg near the mouth of the egg, which was not going before, now slides inside the bottle and falls into the bottle.
Okay. Thank you, ma'am. Nice experiment, Girish.
Okay. Okay, Giri. Thank you.
Thank you. Thank you, ma'am.
Welcome, Giri.
Medine has a question.
On
Ma'am, ma'am, in Ayushika's experiment, ghost is not dead now.
You were looking for the ghost, right?
Yeah, ma'am.
Ayushi, are you there? Ayushi? Unmute Ayushi. He has a question. Can you hear? Can you unmute Ayushi?
Yeah, I'm trying. She's
Yeah.
trying.
There she is. Okay. Ayushi, so we told Medini that there was water in the plate. And then suddenly all the water was drunk by the glass. So we told there is a ghost in the glass which is drinking water.
No, ma'am. Yes, ma'am. There was no
ghost tha kya andar?
No, ma'am. There was no any ghost. It helps because of the air pressure.
Medini, ghost irlilla. Air pressure in the ನೀರೆಲ್ಲ ಕುಡ್ದ್ಬಿಡ್ತು ಲೋಟ ನೀನು ಮಾಡು ಗೊತ್ತಾಗತ್ತೆ ಗೋಸ್ಟ್ ಇದೆಯಾ ಅಂತ ಓಕೆನಾ
Okay, ma'am.
ನೋಡು ನಿಜವಾಗ್ಲೂ ಗೋಸ್ಟ್ ಇದೆಯಾ ಇಲ್ಲ ಆಯುಷಿ ಹೇಳ್ದಂಗೆ ಏರ್ ಪ್ರೆಷರಾ ಅಂತ
Katla ma'am? Katla ma'am, it's me, Jeevan here.
Jeevan, you have a question?
Well, I have to say, the presentation is what? Well, the presentation is wonderful, ma'am. Wonderful one. Yeah, really. I really liked the presentations of the children about how they were displaying their projects, and I also like that shadow thing. Like that. Like the shadow projects. I like those. Maybe it's that many projects have been explained. Really nice. Yeah, really nice.
Vignesh did that shadow play. You liked it, Jeevan?
Yes.
You must try it too.
Oh yes, surely.
Vignesh, are you there? Vignesh can probably show you one or two of it. Can you show Vignesh?
When you hold a torch, when the sun comes, it can see the dark place.
Right. So how do you make a dog or a deer with your hands? Shadow play that you showed. How? Oh, you'll have to hold it like that. What is that?
A deer.
That's a deer.
A shadow.
And where should the light be if you have to see that as a deer? Behind your hand, in front of your hand. Where?
Front of the shadow is here.
You want to show?
When
Okay, probably Vignesh and Jeevan can meet up and learn from each other. Jeevan, possible?
shadows are a dark
Yes,
place
surely, ma'am.
from a light source.
Absolutely. Absolutely, ma'am.
Shadow is so nice.
Yeah, it's fun, to play with shadows.
Yes.
All right. Thank you so much, Vignesh.
Thank you. Thank you, Jeevan.
You're welcome. You're welcome, Vignesh.
All right. Any more questions? Let's get into the next session then. Sagarika, you have one last?
Yeah.
All right.
So my question's for Varshini. So in your experiment, we saw that air expands and contracts, but what are the other properties of air?
ವರ್ಷಿಣಿ ಹಾ ಗಾಳಿ ಏನಾಯ್ತು ನಿನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ?
ಅದು ಉಷ್ಣದಿಂದ ಬಿಸಿಯಾಗಿ ಬಲೂನ್ ಒಳಗೆ ಹೋಗಿ ಬಲೂನು ಹಿಗ್ಗಿತು.
ಗಾಳಿ ಬಗ್ಗೆ ಬೇರೆ ಏನಾದ್ರೂ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಗೊತ್ತಾ ನಿಮ್ಗೆ? ಗಾಳಿ ಬಗ್ಗೆ ಬೇರೆ ಏನು?
ಮ್ಯಾಮ್ ಒಂದ್ ಬಲೂನ್ ಊದಿ ಬಾಟಲ್ಗೆ ಹಾಕಿ ಬಾಟಲ್ನ ಹೋಲ್ ಮಾಡಿರ್ತೀವಿ, ಅದ್ರೊಳಗೆ ಸ್ಟ್ರಾ ಹಾಕಿ ಅವಾಗ ಅದು ನೀರ್ ಬರುತ್ತೆ ಸ್ಟ್ರಾ ಇಂದ.
So Sagarika, she's explaining about another experiment that she's done where she blows a balloon and puts it on the bottle, and then there's a straw inserted midway through the bottle, and ಆಮೇಲೆ balloon ಏನಾಯ್ತೆ?
ಬಲೂನ್ನ ಊದಿ ಬಾಟಲ್ ಹಾಕಿರ್ತೀವಲ್ಲ, ಅದ್ರದ್ದು ಗಾಳಿ ಹೊರಗೆ ಹೋಗ್ತಾ ಇರುವಾಗ ಸ್ಟ್ರಾ ಇಂದ ನೀರ್ ಬರುತ್ತೆ, ಬಲೂನು ಸಣ್ಣ ಆಗುತ್ತೆ.
There's water filled in the bottle. The air from the balloon goes into the bottle, and then the water comes out of the straw. So she's done that experiment on air.
Okay, nice. Thank you.
All right.
Thank you.
Vritti, we'll have another round of question and answer session later towards the end of the session, okay? So we'll definitely give you a chance then. We'll move on now. Let's give a big round of applause to everybody. Thank you so much, children. We will continue. Sufyan.
Hi all, my name is Sufyan. Ayan. Hi all, my name is Sufyan. I have Yukta with me. Yukta, what do you do in your free time?
I do cycling.
Really? Do you know how it works?
Yes, you just have to sit straight on the seat and pedal. If you tilt at an angle, you lose balance.
That's what Aditya is showing us, how cycle works. And Sudan will tell about angles.
And for those of you who like indoor fun, Rahul will show how Lucky 40 is played.
Talking of numbers,
Hey Adi, what are you doing?
I am playing with cycle.
Okay. Can you tell me the parts of cycle?
Yes. Handle, seat, pedal, wheel.
Okay.
One wheel at the front, one wheel at the back. Wheels are circle in shape. Wheels are my favorite.
Hey Adi, can you tell me why the wheels are circle in shape?
Yeah.
Okay.
Now I am going to show
Why the wheels are circle in shape?
Okay.
Wheels are rotating nicely. Now I am going to replace circle wheel with triangle wheel. I have put 2 triangle wheels, one in the front, one in the back. Wheels doesn't rotate.
Okay. So,
The wheel should be circle in shape.
okay, Adi.
Adi, does the gym cycle move?
No,
Why, Adi?
I will just do.
What you will do?
I will do that. I will do
Hmm.
cycling.
Cycling, yes. Here also you are doing cycling, na? But the lion cycle is moving, correct? See? Cycle, cycle and show pedal and see. Doing, yes.
The lion cycle is moving.
Yes.
Lion.
So same thing you are doing, no? You are pedaling in the gym cycle also, correct?
Yes.
Why gym cycle does not move, Adi?
I will just pedal.
You are pedaling, I know. But why?
I don't know.
You don't know.
I don't know.
Go touch and see and find out
Go touch and see and find out, Adi.
why it is not moving.
And I cycle.
Gym cycle, obviously, yeah, Adi.
Obviously. See?
The lion cycle, what does it have? So it moves, Adi.
Pedal.
Pedal it has. Yes.
The gym cycle is not moving.
Not moving. What is not there, Adi? What is not there?
Stand.
Stand is there. This is the stand. That's why this is the stand, no? What is not there?
I don't know.
Pedal is there. Stand is there. What else you should have to move, Adi? What else makes the cycle move? Enna rotate agon cycle. What will rotate? Nicely.
Circle wheel.
Circle wheel. Is it there? Check, check. Check.
Yes.
That is stand wheel. Back side. Wheel is not there. That you are touching the stand wheel. That will not move.
Aditya, what are you doing?
I am doing gym cycle.
Oh, does the cycle move?
No,
Why?
because it doesn't have wheel.
Oh, is it? Okay. Can we check your line cycle?
Yes.
Go.
I can check my tiger cycle.
Oh, okay, tiger cycle. Okay, let's go. It is in the hall. Go.
Lion cycle.
Does this cycle move?
Yes, it moves because it has wheel. Because the wheels are circle in shape.
Oh, okay.
Adi, how are you able to ride the cycle?
Nicely.
Nicely. What do you do to ride the cycle, Adi?
I will put music.
You will put music. Okay. Put and show. Okay. Now you have kept. Then what do you do?
I will ring the bell.
Okay. But how does the cycle go forward? Front? When does it go, friend?
Now.
Now what did you do now? What did you do now with the legs, Adi?
I kept pedal.
You pedaled the cycle. That's why is it going front?
Yes.
Okay. And what will you do to stop the cycle, Adi?
Put brake.
Okay, go in front and put brake. Go front and put brake. Now what happened, Adi?
It stopped.
Cycle stopped. Okay.
1, 2, 2.
Hey Adi, do you know why you are not falling down?
Yes.
Why?
The stand is there.
Show the stand, Adi, where it is. Okay. That supports the cycle and you, right?
Yes.
Okay. One more question, Adi. Do you know when you go in front, put brake? Why did the cycle stop, Adi?
I have put brake.
Okay. And do you know why it stopped? You have put brake, yes?
I don't know.
What happens? You will learn later. There is something called as friction. What?
Friction.
You will explore that later, okay?
Okay.
Thank you.
My name is G.S. Sudan, studying in 6th standard in Gitanjali All India Senior Secondary School, Erode. I am going to explain about angles and its types. First, what is an angle? An angle is formed between two rays which has common starting points. There are 6 types of angles and I am going to say it one by one by using my hands. Consider my left hand as one ray and right hand as another ray. The first angle is acute angle. It will be like this, which is more than 0 degree and less than 90 degree, then it is called as acute angle. An angle which measures exactly 90 degree, then it is called as right angle, like the letter L. An angle which measures more than 90 degree and less than 180 degree, then it is called as obtuse angle. An angle which measures exactly 180 degree, then it is called as straight angle. An angle which measures more than 180 degree and less than 360 degree, then it is called as reflex angle. An angle which measures exactly 360 degree, then it is called as complete angle. If a ray completes a full rotation, then it is called as complete angle. Imagine you are sitting on a chair. In the chair, we can do all the angles except reflex angle. If we do reflex angle, then our head will be on the floor. By sitting on a chair, we can do many angles. The angles are acute angle, right angle, obtuse angle, straight angle. Doing the reflex angle is very difficult. Thank you.
My Yakipati game madam, cards and abacus kodu.
Abacus kodu.
Put the is 9. 1 here. Add 1 ಗೆ ಬೀಳ್ಸಿಲ್ಲ. 1 and what makes 10? 9. Add 10 here, 9. 5, 6, 7, 8, 9. Amma's score is 10. 5 cups. Set, add 5. My score is 15. 3 cups. Add 3. 1, 2, 3. Mama's score is 18. 6 spades. Add 6 ಮಾಡಕ್ಕ ಬೀಚಿಲ್ಲ. 6 and what makes 10? 4. Here 4 ಮಾಡಕ್ಕ ಬೀಚಿಲ್ಲ. 4 ಮಾಡಕ್ಕ ಬೀಚಿಲ್ಲ. 4 and what makes 5? 1. Here 5. Set 1. My score is 24. 4 diamonds. Add 4 ಮಾಡಕ್ಕ ಬೀಚಿಲ್ಲ. 4 and what makes 5? 1. Set 5 here 1. Amma's score is 28. 8 diamonds. Add 8 ಮಾಡಕ್ಕ ಬೀಚಿಲ್ಲ. 8 and what makes 10? 2. Set 10 here 2. 1, 2. My score is 36. 7 diamonds. And 7 diamonds. At 10 here 3 ಮಾಡಕ್ಕ ಬೀಚಿಲ್ಲ. 3 and what makes 5? 2. Here 5. Set 2. 1, 2. Amma's score is 43. Amma is the winner.
Yes.
Good number game. Talking of numbers, do you know how number system works? Let's hear from Kavya. Let's hear from Kavya.
Hi friends, today we're going to talk about number systems. You must be thinking, what about them? Everyone knows number systems, but this is a bit different. So, we all use numbers in our lives. We don't even think about it much. And we can write them simply enough. For example, if you want to write 123, you would just write the numbers 1, 2, 3. Or if you wanted to write 35, you would just write the numbers 3, 5. But when you think about it, it's amazing that with only 10 numbers, 10 digits from 0 to 9, we can write every single number from 1 up to infinity. This is because we use the concept of place value, which is where the location of a digit in the overall number changes the value it holds. For example, in 123, 1 is 100 because it's in the hundreds place. 2 is 20 because it's 2 in the tens place. And 3 is only 3 because it's in the units place. Let's understand this a bit better with an activity, because only talking and theory is kind of boring. For this activity, let's assume that you're a shopkeeper and you have to weigh things. Now in our decimal system, you have 1 in the units place, then from to its left is 10, then 100, and then other multiples of 10. Let's imagine that you have a weight similar to this. So you have weight of 1 kilogram, 10 kilograms, 100 kilograms, etc. Now, using these, if you had to weigh, for example, 35 kilograms, what you would do is take 3 from the tens and 1 and 5 from the ones. So 35. Okay, so the fun fact, the decimal system has been made the way it has simply because we humans have evolved with 10 fingers. Now let's imagine that there's an alien shopkeeper, and those aliens have only evolved with 2 fingers. Now for their weight, let's imagine they have 1 and then all the multiples of 2. So 1, 2, 4, 8, 16, etc. So now, if they had to weigh 35, and also I forgot to mention, let's imagine they only have 1 of each type of weight. Now, if they try to weigh 35 on their system, then they would take 1 of the 32 weight, 0 of 16, 0 of 8, 4, and then 1 of 2, and then 1 of 1. So, in their numbers, this would be written as 1, 0, 0, 0, 1, 1. This exact system, using only 2 digits 0 and 1, and doing place values of powers of 2, is called binary. It is amazing that we can express every number from 1 to infinity in binary as well, though of course it will use a lot more zeros and ones. Another really amazing fact is that the binary system was first described by Maharishi Pingalacharya 2200 years ago in a book called Chandashastra. This binary system is the language of all computers. Computers use it for everything they do, even if that is playing music, showing pictures, playing sounds, and even playing video games or programming them. Computers use what are called transistors, which represent 0 if they are off and 1 if they are on. Obviously, computers need a lot of these transistors to get everything done. In fact, in the first personal computers released in the 70s, the number of transistors was 2250. Now in the Core i7 used in most laptop processors these days, the number is somewhere around 3.2 billion transistors. How they cram so many transistors into one small computer chip may be something discussed in a future Curious Minds video. Who knows?
Amazing! Our sages knew so much about number.
Talking
Amazing! Our sages knew so much about numbers. Let's now understand how measurements were done in olden days. Pramanjika.
Talking of measurements, I had fever the other day, but I used a thermometer and I couldn't see the readings. Yukta, do you know how it works?
Don't worry. Bharat will show us how. And wait, Sagarika Akka will show how measurements can be accessible to us. Till 15, 16.
Hi Ansika, what are you doing?
I am measuring the length of pencil.
Very good. What's the length of the pencil?
16 centimeter, Mama.
Very good. Then how will you measure the distance from your house till your school?
Kilometer.
Very good. Now, what about weight? How will you measure the weight of light objects?
We measure it in grams.
Okay. Now, how will you measure the weight of heavy objects?
Kilogram.
Very good. Now, can you please tell me how liquids can be measured?
In liters and milliliters.
People do measurements in olden days, Nisika?
They use their body parts or measurements.
Very good. Which body parts are they used for measurement?
Hands,
Okay.
fingers,
Hmm.
palm,
Okay.
feet.
Okay.
This is span.
Hmm.
This is span. Length from thumb to little finger. This is cubit figure to the elbow.
Very good.
This is inches tip to the line.
Summary.
Now foot length.
The distance from the tip of the toe to the ankle.
ಮೊದಲು ಫ್ರೂಟ್ಸ್ ಮತ್ತೆ ವೆಜಲ್ಸ್ ಫ್ರೂಟ್ಸ್ ಮತ್ತೆ ವೆಜಿಟೇಬಲ್ಸ್ ಹೆಂಗೆ ಅಳತೆ ಮಾಡ್ತಿದ್ರಿ?
ತಕ್ಕಡಿಯಲ್ಲಿ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ. ನೋಡು, ಈ ತರ ತಕ್ಕಡಿ ಕಲ್ಲು ಅಂತ ತೂಕದ ಕಲ್ಲು. ಇದು 50 ಗ್ರಾಮು, ಇದು 100 ಗ್ರಾಮು, ಇದು 200 ಗ್ರಾಮು,
ಏ ಜರ ಚಿನ್ನ
ಇದು 500 ಗ್ರಾಮು. ಇತ್ತಲ್ಲ 500 ಗ್ರಾಮು. ಇದು 1000 ಗ್ರಾಮು, 1 kg. ಇದು ಇದೆಲ್ಲ ತಕ್ಕಡಿಯಲ್ಲಿ ಇಟ್ಟು ತರಕಾರಿ, ಹಣ್ಣು, ದಿನಸಿ ಎಲ್ಲ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ. ನಾನು ನಿನ್ನ ಕೈಯಿಂದಾನೆ ತಕ್ಕಡಿ ಥರ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ. ಇದು ನಿನ್ನ ತಕ್ಕಡಿ, ಇದು ಕೈ. ಇದು ಒಂದು ಕಡೆ ಇಡ್ತೀನಿ, ಇದು ಒಂದು ಕಡೆ ಇಡ್ತೀನಿ. ಯಾವ್ದು ಜಾಸ್ತಿ ಭಾರ ಇದೆ, ಯಾವ್ದು ಹಗುರ ಇದೆ ಹೇಳು. ಕೈ ಹಿಂಗ್ ಮಾಡು.
ಇದು ಜಾಸ್ತಿ ಬರ ಇದೆ, ಇದು ಹಗುರು ಬರ ಇದೆ.
ಇದು kg, ಇದು ಅರ್ಧ kg. ಜಾಸ್ತಿ ಇದೆಯಾ ಅದು ನನ್ನ ಕೈ ಕೊಡು. ಹನ್ಸಿಕಾ ನನ್ನ ಕೈ ಇಟ್ಕೊ. ಮೊದಲು ಈ ತರ ಒಂದ್ ಕಡೆ ತೂಕದ ಕಲ್ಲಿಟ್ಟು, ಇನ್ನೊಂದ್ ಕಡೆ ಅಕ್ಕಿ ಇಲ್ಲ ಬೇಳೆ, ತರಕಾರಿ, ಹಣ್ಣು ಇಟ್ಟು ಎರಡು ಹಿಂಗೆ ಒಂದೇ ಬ್ಯಾಲೆನ್ಸ್ ಬರಂಗೆ ತಕ್ಕಡಿ ತೂಕ ಮಾಡ್ತಾ ಇದ್ದಿದ್ದು. ಗೊತ್ತಾಯ್ತಾ?
ಗೊತ್ತಾಯ್ತು. ಅಜ್ಜಿ ಲಿಕ್ವಿಡ್ಸ್ ಎಲ್ಲ ಹೆಂಗೆ ಮೆಜರ್ ಮಾಡ್ತಿದ್ರಿ ಅಜ್ಜಿ?
ಮೊದಲು ಈ ತರ ಸೇರು, ಇದು ನೋಡು, ಇದು ಇದು ಸೇರು, ಇದು ಅರ್ಧ ಸೇರು, ಇದು ಪಾವು, ಇದು ಅರ್ಧ ಪಾವು, ಇದು ಚಟಾಕು ಅಂತ. ಇದರಲ್ಲಿ ಇದ್ರ ಅರ್ಧ, ಇದು ಅರ್ಧ ಪಾವು, ಅರ್ಧ ಸೇರು ಅಂದ್ರೆ ಅರ್ಧ 2 ಪಾವು, ಇದ್ರ ಅರ್ಧ ಇದು, ಇದ್ರ ಅರ್ಧ ಇದು, ಇದ್ರ ಅರ್ಧ ಇದು. ಇದರಲ್ಲಿ ಹಾಲು, ಎಣ್ಣೆ, ತುಪ್ಪ ಎಲ್ಲ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ. ಅಕ್ಕಿ ಬೇಳೆನ ಇದರಲ್ಲೇ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ದಿದ್ದು. ಜೋಳ, ರಾಗಿ, ಅಕ್ಕಿ ಬೇಳೆ ಎಲ್ಲ ಇದರಲ್ಲೇ, ಸಕ್ಕರೆ ಎಲ್ಲ ಇದರಲ್ಲೇ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ. ಇವಾಗ ಇದು ಅರ್ಧ kg ಹಾಕೋಣ, 1 kg ತೆಗ್ದು ನೋಡಿ. ಇವಾಗ ಇದಕ್ಕೆ ಹಾಕ್ತೀನಿ. ನೋಡು, ಎಷ್ಟಿದೆ ಇವಾಗ? ಫುಲ್ ಇದೆಯಾ, ಅರ್ಧ ಇದೆ?
ಅರ್ಧ.
ಇದು ಅರ್ಧ kg, ಇದು ಅರ್ಧ kg. ಅರ್ಧ ಅರ್ಧ ಹಾಕೋಣ.
ಅಜ್ಜಿಯ
ಇಟ್ಕೊ. ಇದು ಇವಾಗ ಇದನ್ನ ಇದಕ್ಕೆ ಹಾಕೋಣ. ಇದ್ರಲ್ಲಿ ಎಷ್ಟಾಯ್ತು? ಫುಲ್ ಇದೆಯಾ, ಅರ್ಧ ಇದೆ?
ಅರ್ಧ ಇದೆ.
ಇದರಲ್ಲಿ
ಫುಲ್ ಇದೆ.
ಖಾಲಿ ಅಲ್ಲ, ಅರ್ಧ ಮಾಡೋಣ.
ಅರ್ಧ ಮಾಡೋಣ.
ಬಾ ಮಾಡು. ಇದು ಹಿಡ್ಕೊ ಹಿಂಗೆ. ಇದ್ರಲ್ಲಿ ಎಷ್ಟಿದೆ? ಇದ್ರಲ್ಲಿ ಎಷ್ಟಿದೆ?
ಅರ್ಧ.
ಇದರಲ್ಲಿ ಫುಲ್ ಇದೆ. ಇದನ್ನ ಅರ್ಧ ಮಾಡೋಣವಾ? ನೋಡು, ಇದಿಟ್ಕೊ. ಇದು ಅರ್ಧ ಪಾವಿಂದ ಚಟಾಕಿಗೆ ಹಾಕ್ತಾ ಇದೀಯಾ? ಇವಾಗ ನೋಡು, ಇದ್ರಲ್ಲಿ ಎಷ್ಟಿದೆ, ಇದ್ರಲ್ಲಿ ಎಷ್ಟಿದೆ, ಇದ್ರಲ್ಲಿ ಎಷ್ಟಿದೆ?
ಅರ್ಧ.
ಇದ್ರಲ್ಲಿ ಚಟಾಕು ಇನ್ನಷ್ಟ ಇದೆ ನೋಡಿ. ಫುಲ್. ಹನ್ಸಿಕಾಯಿ ಇದ್ರಲ್ಲೆಲ್ಲ ಎಷ್ಟೆಷ್ಟಿದೆ ನೋಡಿ ಹೇಳು. ನೋಡು, ಇದ್ರಲ್ಲಿ ಎಷ್ಟಿದೆ ನೋಡು.
ಅರ್ಧ.
ಇದ್ರಲ್ಲಿ
ಅರ್ಧ.
ಅದ್ರ ಪಕ್ಕದ್ದು
ಅರ್ಧ.
ಇದ್ರಲ್ಲಿ ಅದು ಬಿಡು. ಇದ್ರಲ್ಲಿ
ಅರ್ಧ.
ಇದು
ಫುಲ್.
ಹನ್ಸಿಕಾಯಿ ಮೊದ್ಲು ಜೇನುತುಪ್ಪ ತುಪ್ಪ ಎಲ್ಲ ಈ ತರಾನೇ ಅಳತೆ ಮಾಡ್ತಿದ್ವಿ. ಒಂದು ಇದು ಬ್ಯಾಂಬೂ ಸ್ಟೆಮ್ ಇರ್ತಿತ್ತು, ಇದೇ ತರ ಸೇಬ್ ತರಾನೇ ಇರ್ತಾ ಇತ್ತು. ಅದ್ರಲ್ಲಿ ಹಾಕಿ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ. ಗೊತ್ತಾಯ್ತಾ?
ಗೊತ್ತಾಯ್ತು. ಅಜ್ಜ, ನೀವು ಮೊದ್ಲು ಬಟ್ಟೆ ಹೆಂಗೆ ಅಳತೆ ಮಾಡಿದ್ರಿ?
ಟೇಪ್ ಇರ್ಲಿಲ್ಲ, ಈ ತರ ಗಜ ಇತ್ತು, ಗಜದಿಂದ ಈ ತರ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ. ಈ ತರ ಅಳತೆ ಮಾಡ್ತಾ ಇದ್ವಿ.
ಅಜ್ಜ, ಗಜ ಅಂದ್ರೆ ಏನು?
ಇದು ಗಜ. ಒಂದು ಗಜಕ್ಕೆ 36 ಇಂಚು, ಅರ್ಧ ಗಜಕ್ಕೆ 18 ಇಂಚು.
Good morning, everyone. My name is Bharat. I study in class 5. Vidyadrishti. This is my sister Bhuvan. She studies in 6th grade. Bhuvan, do you know when you got fever last time, what did mommy use?
Mommy used a thermometer to check my temperature.
Bhuvan, do you know how this thermometer works?
I don't know.
Okay, then let's do a small experiment. Same for this experiment are 50 ml of water, same amount of surgical spirit, few drops of red food coloring, molding clay, straw, and not least a funnel, a bottle and a funnel. Now I'm putting the funnel carefully in the bottle. Is it any 50 ml of water into the funnel and it's going in the funnel. It's in the bottle as you can see now. Now I'm taking the same amount of surgical spirit as I said before. And it's going carefully in the funnel and it's passing through the funnel. Now it's in the bottle. Now I'm going to keep adding 2 drops of lead food coloring into the funnel. Now I'm going to remove the funnel carefully out and I'm going to replace it with the straw. Make sure the straw doesn't touch the bottom of the bottle. Now I want to seal it with molding clay. I have sealed the bottle with the molding clay. I'm going to keep the bottle carefully inside the hot water and watch the water level increase in the straw. 3. Start. The water level carefully rises in the straw. Make sure it doesn't get too hot. Same way, a clinical thermometer, when it's put on a person's body, when the person's body is hot, the mercury rises, and which number it stops, that much hot is the person.
Hello everyone, my name is Sagrika and today I'm going to show you how to measure temperature using a DS18V20 probe. So temperature is usually measured using a thermometer, but that is not accessible. So this is an attempt to make a device that is accessible to measure temperature. This is a DS18V20 probe. This is an Arduino board. And this is my computer on which there's a small program which collects the data from the probe and displays it on the screen. And my screen reader NVDA reads it out loud. So first I'm going to dip the probe into a glass of water. So the temperature is 24.19 degrees Celsius. Now I'm going to remove it from that glass and put it into a different glass. So now the temperature is 44.25 degrees Celsius. So this way of measuring temperature is more accessible. Thank you.
I wonder what all we can measure.
Everything.
Oh.
Everything. We can measure the depth of the ocean to distance to the sun. We have Ram uncle with us. It seems he's an astrophysicist. Shall we ask him? Ram uncle, I have a small project on artificial satellite. I would like you to watch it. I was wondering how information come. How will information come from satellite? And how can we understand them?
Hello, can you hear me? Okay, you wanted to know how information come from a satellite. Okay, so satellite transmits information to the Earth in the form of electromagnetic waves. Electromagnetic waves are very similar to light. So if you talk on your mobile phone, what happens? When you talk on your mobile phone, your sound is converted to electromagnetic waves and transmitted to the nearest mobile tower. And from that tower, it transmits to another tower and another tower. till it reaches the person you are talking to. And from that tower, it transmits to the mobile phone of that person. So all this information transmission happens in the form of electromagnetic waves, radio waves. Similarly, a satellite which is in the space can transmit information to the Earth in the form of electromagnetic waves. Do you have another question?
Thank you very much, sir. Thank you so much, sir.
Thank you.
We will have
You're
a
welcome.
Q&A with you, sir, just after a few more experiments. Yukta, will you continue?
Sure.
Yes, ma'am. Sufyan, wait. Savarika is showing how data analysis is done in using Excel. Pranav will show us how graphs can be held.
And data analysis is happening in little Rahul's house. Ram uncle, can we discuss with you after these presentations?
Of course, we can discuss after this.
Magnet to ಬೀಸಿದ ಚಿಕ್ಕ ಆಗುತ್ತೆ. Magnet to ಬೀಸಿದ ಚಿಕ್ಕ ಆಗುತ್ತೆ. ಗ್ಯಾಸ್ ನಿಮಗೆ ಚಿಕ್ಕ ಆಗೇ ಇಲ್ಲ. Magnet sticks to iron gate. Not sticks to wood door. Magnet sticks to cycle wheel. Magnet sticks to iron wheel. Magnet will not stick to sofa. Magnet sticks to fridge. Magnet sticks to knife. Magnets not sticks to plastic handle. Magnet sticks to scissor. Magnet will not sticks to plastic handle. Magnet to keys stick ಆಗ್ತೈತೆ. Magnet to stick ಆಗೇ ಇಲ್ಲ. Eraserಗೆ stick ಆಗೇ ಇಲ್ಲ. Magnet will not stick to paper cups. Magnet sticks to coin. Switchboardಗೆ stick ಆಗೇ ಇಲ್ಲ. TVಗೆ stick ಆಗೇ ಇಲ್ಲ.
Rahul's mother converses with him to analyze what is it that makes the magnet to stick.
Magnet sticks to iron gate, fridge, keys. Okay. Magnet will not stick to car tie.
Car tie ಏನ್ ಮೆಟೀರಿಯಲ್?
Plastic.
ಪ್ಲಾಸ್ಟಿಕ್. ಇನ್ನ ಏನಕ್ಕೆ ಸ್ಟಿಕ್ ಆಗಲ್ಲ?
Paper cups.
ಪೇಪರ್ ಕಪ್ಸ್ ಅಲ್ಲಿ ಮೆಟೀರಿಯಲ್ ಏನು?
Paper.
ಓಕೆ, ಇನ್ನ ಏನಕ್ಕೆ ಸ್ಟಿಕ್ ಆಗುತ್ತೆ?
ಸೈಕಲ್ ವೀಲ್ಸ್ಗೆ ಸ್ಟಿಕ್ ಆಗುತ್ತೆ.
ಸೊ ವೀಲ್ಸ್ ಅಲ್ಲಿ ಮೆಟೀರಿಯಲ್ ಏನು? ಮೆಟಲ್. ಮ್ಯಾಗ್ನೆಟ್ ಮೆಟಲ್ ಸ್ಟಿಕ್ ಆಗುತ್ತಾ?
ಮೆಟಲ್ಗೆ ಸ್ಟಿಕ್ ಆಗಿದೆ.
ಮ್ಯಾಗ್ನೆಟ್ ಸ್ಟಿಕ್ಸ್ ಟು
ಮೆಟಲ್.
ಮೆಟಲ್ಸ್. ಓಕೆ, ಮ್ಯಾಗ್ನೆಟ್ ಇಂದ ಏನಕ್ಕೆ ಸ್ಟಿಕ್ ಆಗಲ್ಲ?
ಗ್ಲಾಸ್ ವಿಂಡೋ.
ಗ್ಲಾಸ್ ವಿಂಡೋ ಅಲ್ಲಿ ಮೆಟೀರಿಯಲ್ ಏನು?
ಗ್ಲಾಸ್.
ಇನ್ನ ಏನಕ್ಕೆ ಸ್ಟಿಕ್ ಆಗಲ್ಲ ಮ್ಯಾಗ್ನೆಟ್?
ಮ್ಯಾಗ್ನೆಟ್ ಗ್ಲಾಸ್ಗೆ ಸ್ಟಿಕ್ ಆಗಲ್ಲ.
ಓಕೆ. ದೆನ್
ವುಡ್.
ಮ್ಯಾಗ್ನೆಟ್ ಏನೇನು ಸ್ಟಿಕ್ ಆಗುತ್ತೆ?
ಆಮೇಲೆ ಕಾಯಿನ್ಗೆ ಸ್ಟಿಕ್ ಆಗುತ್ತೆ.
ಇವೆಲ್ಲ ಕಾಯಿನು, ಕೀ ಇವೆಲ್ಲ ಏನ್ ರಾಹುಲ್?
ಮೆಟೀರಿಯಲ್ಸ್.
ಮೇನ್ ಮೆಟೀರಿಯಲ್ಸ್ ಅವೆಲ್ಲ.
ಮ್ಯಾಗ್ನೆಟ್ ಸ್ಟಿಕ್ಸ್ ಟು ಮೆಟಲ್.
ಮೆಟಲ್ಗೆ ಸ್ಟಿಕ್ಸ್ ಆಗುತ್ತೆ ಇವೆಲ್ಲ ಮೆಟಲ್ಸ್. ಓಕೆ.
Hello Sufyan, how are you? I'm fine, how are you? Yeah, I am also fine. What are you doing? I'm doing the model of artificial satellite. That sounds amazing. What is artificial satellite? Artificial satellite is man-made object sent into space by scientists. It is launched into space by rockets to orbit around the Earth. Has any country sent their artificial satellite? Yes, Sputnik 1 was the first man-made satellite. It was launched into space by USSR in 1957. Has India sent any artificial satellite? Yes, India launched the first satellite called Aryabhatta in 1979. What are the uses of artificial satellite? This satellite takes pictures of long movement and helps to forecast weather. Communication satellite helps people all over the world to talk to each other. It takes pictures of Earth and helps to spot problems like forest fire, glaciers and floods. That was a great information. Welcome. And how are you going to make artificial satellite? I'm going to make this satellite. We need two cardboard, one big and one small. We need one pencil, color paper, and we need one empty box, any empty box, some straws and cardboard small circle pieces for antenna. The pencil inside the color paper and roll it like this. And stick it with the glue. Now the pencil is ready with the color paper, and we need cardboard circle pieces. First take the pencil and place it inside the cardboard like this. It should stand straight. Now take two cardboard pieces of circle. This much small size. Take this color paper. Stick it on the circle. Let it get dry. And apply little glue on the back side of the circle. Keep it in the center of the antenna. Is it dry? We should cover the box entirely with color paper. Take one ice cream stick. So here, slowly push it in the slit. So here. It came out here. Now the communication device is ready. Now I'm going to communication device on the map. So interesting to watch. Keep this silver foil on it. This is how it looks after once it's done. Solar panels. Two solar panels and two ice cream sticks. Take glue. Apply glue on the ice cream stick. Now stick to the solar panels. Do this with another one also. Let it dry. I'll stick to the communication device. This is how it looks. Hold it for a minute. How to make uplink and downlink antenna. Big and small. Yellow is small Orange is big. Cut the center circle. This is drawn over here. This is a circle. You have seen each other's skies this, right? Make it like that and stick both the sides. And the both uplink and downlink antenna. And after that, I made for antenna. I stick such this. I stick this antenna. And this is stick paper cups base. This is how it looks. For uplink antenna, I have a stick like this straws for the antennas. To stick it this, we need this pieces. I'll show you how. Box. Now I'm going to stick the communication box. I stick it like this. Fix the uplink and downlink antenna over here. Yay! This is how your artificial satellite looks. This is your uplink antenna, this is downlink antenna. This is two solar panels, and this is a communication box. This is the another model which Anand says with paper strips.
What is it regarding?
Solar
Please don't call
panels.
me for feedback.
See, this is the paper strips. This is uplink, this is downlink, this is solar panel, and this is also solar panel. This is communication device. If you remember, there is a pencil inside the stand. And this is how it looks.
Hello everyone, my name is Sagarika and today I'm going to show you how to analyze data using Excel. Data analysis is when raw data is collected and new information is discovered. Data analysis is used in business and science and helps to make better decisions. This is my computer and I'm using a screen reader called NVDA and you will hear that in the background. In order to use Excel, we will be using shortcut keys instead of the mouse. So, in this example, I have a spreadsheet with marks of students. So, in the first column is the group number, and the second column has gender, the third one has math scores, fourth one has language scores, and the fifth one has science scores. So first, I'm going to filter by group. And before that, I'm going to create a table by pressing Ctrl T. Now I'm going to press Alt Shift down arrow. And now I have a few filtering options. Now I'm going to uncheck all options except for group B. Now only group B results are visible. Now I'm going to select them by pressing Ctrl Shift 8 and copy them and paste them in another sheet. Now I'm going to calculate average math marks for group B students. So now I'm going to use the formula to calculate average, which is equals to ABERAGE in parenthesis C2 colon C10 and close the parenthesis and press enter. So now I have the average. Now I'm going to filter again, this time by gender. And first, I'm going to create a table by pressing Ctrl T. Now I'm going to press the Alt Shift down arrow. I'll uncheck male. So now only the results of females in group B are visible. Now I'm going to select them all by pressing Ctrl Shift 8, copy it, and paste it in a new sheet. Now I'm going to calculate the average math score for female students in group B. So I'm going to type the formula equals average in brackets C2 colon C9, and now I got the average. So this is how you analyze data in Excel. The data analysis can be used to calculate values such as average and median, and can be used to find the relation between different variables. Spreadsheet applications like Excel are a useful tool for data analysis. Thank you.
Guys, Pranav here, and today I'm going to be showing you how I use the audio graphing calculator, a software to plot graphs, to be able to listen to graphs, plot them, and just work with them. So graphs are very important because they let you visualize certain data. They let you visualize it over a period of time. I use it for the same purpose. I use it to visualize shapes of curves such as parabolas, cubics, and exponential curves. I use it for trigonometry, and I use it because I want to visualize certain other data that I've either got in a question from school or from some other project that I do. However, using stuff like the graphing paper is not always convenient because A, I can't always carry it with me as it's kind of cumbersome, and also B, because it can't display values with great levels of accuracy due to just size limits. So here's where the graphing calculator comes in handy, because I can plot graphs, as I said, and listen to them. And that's what I'll be showing you here. So you can get this software off Google, and for my screen reader, I'm using NVDA. So I'm going to navigate to the audio graphing calculator, and here we have a few tabs. We've got the plot screen, which helps you configure settings.
Wave screen.
That's for configuring certain sounds. You can navigate through these screens with the left and right arrows.
Speech screen.
This is to configure the sort of self-voicing.
Calculator screen.
This is a scientific calculator.
Day1 screen.
Now there are two data sets that you can plot to sort of do comparisons.
Data2 screen.
That's data 2.
Evaluator screen. Matrix screen.
Evaluator and matrix are stuff that I personally never
Calculator
use,
screen.
so I don't really know.
Data1 screen. F open parent.
Okay, so here we have this data. So we've
Data
got,
F open parent X close parent.
that's where you can type your function. I'm hitting tab.
Coordinates button radio button rectangle checked.
That's the type of coordinates you want from your function.
Button statistical description of dataset.
And that gives you sort of a description. So we're going to plot a few types of graphs. The first one is a linear. So let me just do X plus 5. I hit enter and it evaluated. Now, the first thing I'm going to do is hit F3 on my keyboard to show the graphs. For all the F keys, Users with a laptop will have to hit the function key as well.
Graph open.
The graph should be open now. And now if we hit F5, it'll actually play the graph. So let's listen to this curve. So you can really see that it shows you sort of the shape of the line in this case. It's a straight line. Let's do another one. Let's do a parabola. Let's do x squared.
X to the power of 2.
That would sound like this. So it's a very smooth curve.
Backspace 2.
What about a cubic? X cubed.
X to the power of 3.
Sounds like this. I kind of like that sound, to be honest.
Backspace 3.
Let's do a fraction. So 1 by x.
1. Divide x.
And if I hit enter, and now I have 5. The reason this sounds so weird is because it starts out above the x-axis. It never really touches the x-axis, but it dips just before 0, and then it goes right back up after 0 in the second quadrant.
Backspace
Let's
x.
do an exponential, so 2 to the power of x.
To the power of x.
But for the to the power of, or the superscript, by the way, I'm using shift plus 6, which is the caret symbol. And if I hit F5, so it's sort of slightly going up very, very slowly, and then it suddenly goes up because it's an exponential curve. So each time the curve gets steeper. Lastly, what if I want to plot like a sine wave, which does have a function, but it's kind of ambiguous, right? What if I want to plot the points directly? Because let's face it, that's easier. And this is a common occurrence because many a times I have data that I have values for, but do not have a function that generalizes the data. So I can plot in points. What I'm going to do is type in points equal to 9.
P-O-I-N-E-S. 9.
You won't hear a beep when I press enter, but now if I tap twice,
X equals cell contains no data.
we get a table.
F of x equals cell contains no data. X equals cell.
X and f of x. So I'm going to quickly enter the values.
0.
X
X
is
equals
0.
0. F of x equals 0. F of x cell contains equal.
This is
4, 5. X equals 4. F of x. X equals 45.0. F of x equals.
This is
0. 5. F of x equals 0. Cell contains equal.
0.5. This is 9.
9. 0. X equals 9. F of x equals cell contains.
This is
1. F of x cell contains equals.
This is
1, 3, 5. X equals 1. F of x.
This is
0. 5. F of x equals cell contains equal.
This is
1, 8.
180.
0. X equals 1. F of x equals.
This
0. F of x equals cell contains equals cell.
This
2. 2. 5. X equals F of x.
225. This is
Minus 0. F of x equals 5. Backspace 5. Minus 0. 5. F of x equals x equals 220. F of x equals minus 0. Cell x equals cell. 27. 0. X equals 2. F of x equals cell. Minus 1. F of x equals cell. X equals 4. 5. X equals 3. F of x.
315.
Minus 0. 5. F of x equals cell. X equals
0.5 and 5.
3. 0. X equals F of x.
And
0. F of x equals.
now, because I'm on this table, I need to actually hit F4 to evaluate because I'm not in that edit box where I can just hit enter. So if I hit F4,
F open parent X close parent user.
Takes us back to the edit box. And now if I hit F5, we hear this. The reason it sounds like a telephone with someone pressing random buttons and not exactly like a smooth curve is because I've plotted points directly. Had I actually used the function for sine x, it would have actually looked like a smooth wave. But essentially, that is how I use the audio graphic calculator. Again, very useful tool. Really, really helps me when I either just want to see a curve for myself or listen to one, or show a graph to my friends or at a presentation. I hope you found this useful and enjoyed it. And I'll see you later. Bye.
Over to Neerav.
Hi all, this is Neerav. Do you know how we learn about the sun, the planets, and other things in space? We use an instrument called telescope. Today, we have a special guest with us, Dr. A.N. Ramprakash. He builds instruments to study our universe. He is basically an engineer and pursued his PhD in IUCAA, Pune, and a postdoc at Cambridge. He heads the Astronomical Instrumentation Lab in IUCAA and is Associate Program Director of TMT, 30-meter telescope. Hello Ram Uncle, welcome to Curious Minds. Can you please tell us what is TMT?
Hello, can you hear me?
Yes, we can hear you, sir.
Okay, great. You were asking about TMT. TMT stands for 30-meter telescope. It is called 30-meter telescope because the main mirror of the telescope is 30 meters in diameter. 30 meters is a very large size. It's the size of a small football field or a small ground. So it's a very large telescope. Now, the question is, why do you want to make a large telescope, such as a 30-meter telescope? The reason is we want to use the telescope to look at very far away objects like stars, galaxies, etc., which are very, very faint. So as an example, if you want to talk to somebody and that person is sitting right next to you, if that person speaks to you, you are able to hear. But if that person moves away to another building, the next building, and speaks to you, you may not hear unless that person speaks very loudly. If that person shouts, you may hear from the next building. But if that person goes away 1 kilometer and speaks, however loud he speaks, you will not be able to hear because your sound is not loud enough for you to hear from 1 kilometer away. So what do you need to talk to some people who are very far away? You use a telephone. So what does the telephone do? Telephone hears what you are saying, then converts that into electromagnetic signals, some kind of signals, and then transmit to the other telephone, which the other telephone then converts it back to sound which you can hear. So in order to hear very low sound, very small sound or sound from people which are very far away, you use a telephone. Similarly, in the earlier videos, Hansiga, Sagariga, etc., showed you how to make various measurements using other kind of tools like thermometers or that temperature probe she used to measure the temperature of water at different temperatures. So we use various kinds of tools to detect signals and measure signals which are otherwise not accessible to us. It is either too faint, there's very little light, or it is too low that you cannot hear it, or the temperature is too small, you cannot feel it. So you need to use various kinds of tools to measure these quantities. And telescope is the tool which astronomers use to measure light coming from distant stars, galaxies, etc. accurately, so that they can understand what stars are made of, how do they produce light, how are planets formed around stars, how stars take birth and die, how long do they live, etc., etc. All this information we can understand by studying the light coming from the stars, collecting using telescopes, and then again, Sagarika showed, putting them in an Excel sheet or other kind of software, plotting graphs. We can then understand all the properties of the stars, galaxies, and the whole universe itself. So astronomers build telescopes to collect light, study the properties of these objects in the universe, and make better understanding of what our universe is made of. So if you have any other questions related to this, I will be happy to answer.
The forum is now open to children to ask questions to Ram Uncle. Please use raise hand option so we can unmute you. Thank you so much, Ram Uncle.
I can see many hands.
Hi, am I audible?
I can hear you.
Hi, this is Pranav. I had
Hello, Pranav.
hi. Firstly, it was very interesting hearing about TMT. I had actually two questions, which are actually not related as such to TMT, but I've been having, based on this sort of world that we're slowly learning more about, which is outer space, right, or sort of the extraterrestrial area outside our Earth. The first one is actually related to the sort of again, I hope you don't mind me not asking these. The first one is related to the radioactivity that goes on there. So we do know that the sun contains of like fusion reactions that take place, right? How much more of how much ever we know of outer space so far is full of these fusion and fission reactions? Like how much of space is made up of just radioactive reactions that take place?
Okay, that's an excellent question. So what we know is that for fusion reaction, like the one which is happening in the sun, where hydrogen atoms are combined together to form helium atoms at the core of the sun, in the middle, in the center region of the sun. In order for this to happen, there has to be very, very high temperature, several million degrees centigrade temperature, and very, very high pressure. In the previous videos, we heard about air pressure, various kinds of pressure, what kind of effect it has, and we also learned about temperature. So temperature and pressure has to be very, very high in order to, unimaginably high, millions of degrees temperature and very high pressure in order for these fusion reactions to happen. So in the center of the stars, fusion reaction happens. In the center of many galaxies, there might be objects like massive black holes, etc., which also may lead to various kinds of atomic reactions and radioactive activities. But what happens is all the objects which we see in the universe, the stars, the galaxies, etc., are only a very, very tiny part of the whole universe, very tiny part. So most of the universe is empty. Almost no material is there in most of the universe. That is why we call it space. It is basically empty space. So in empty space, naturally, there is no reaction, there is no chemical activity or physical activity. It's really empty space. So almost all the action, like the fusion reaction, other kind of interactions, etc., happen in the objects like stars, galaxies, etc.
Thank you so much. I also have another question, which is a much smaller question. So earlier on there was something asked about satellites, and the way even someone talked, I believe it was Sufyan who talked about artificial satellites. So I wanted to ask you, when artificial satellites have to inevitably transfer this information over to devices such as TVs, and they go through the antenna, they're picked up by the antennas and all that, how much attenuation or loss of energy takes place? And if there's a lot of it, are there steps that are actually currently being taken, or how can we reduce this attenuation that takes place to sort of get a clearer output from these satellites?
Yes, that's an excellent question. Again, I don't know how many people in the audience would fully understand my answer, but let me try. You were asking about attenuation, which is the loss of signal. When a signal is transmitted via transmitter and it passes through a medium, like in the case of the satellite and a ground station, here the signals have to pass through the Earth's atmosphere. And as it passes through the Earth's atmosphere, its signal strength reduces. It becomes weaker and weaker as it passes through the atmosphere. And this is called attenuation, the reduction of the signal strength. And this is a very common phenomenon. Any signal you transmit through any medium, in general, its strength weakens and it becomes weaker and weaker as it travels further and further. Now, depending on the particular kind of communication, you can reduce attenuation or reduce the weakening of the signal by different technologies. For example, in the past, if you want to communicate from, say, India to the United States, you will use radio waves, which will transmit up to the atmosphere, then transmit back to the other station, receiving station at the other end, and that has to pass through the atmosphere twice, and therefore the signal will become very weak. And therefore, in the olden days, the communication was not very reliable. It was not possible to communicate as clearly as we do now. But nowadays, we use optical fibers or various kinds of cables, which go under the Atlantic Ocean or under land and ocean and connect between this transmitting and receiving station. And the attenuation within the optical fibers are very little compared to what happens in the atmosphere. So for communication transmission, you use, for example, things like optical fibers, so that the attenuation or the reduction in the signal strength is reduced. But you cannot use a optical fiber to connect a satellite to Earth. When the satellite has to transmit a signal back to Earth, it has to travel through the atmosphere anyway. So what you do is you choose particular kinds of radio waves which are less attenuated by the atmosphere. So depending on the wavelength of the radio waves you use, the attenuation changes. So you use wavelength of particular radio frequencies or radio wavelengths which are less attenuated by the atmosphere than other wavelengths. You can also use laser, for example. Laser communication for deep space communication is also becoming possible. That's a new technology which is coming up. Or you can also do one thing. You remember the experiment earlier, which was shown by someone, where there were two dish antennas which were communicating to each other, a transmitter antenna, uplink antenna, and a downlink antenna. So if the uplink antenna sends the signal in a way which is spreading like that, by the time it reaches the downlink or the receiving antenna, it becomes very weak. Instead of spreading the signal like that, if it directs the signal exactly pointedly to the other antenna, the signal will not become weak. It will not attenuate. So depending on the situation, the solution may be different. It could be either using optical fibers or using good wavelengths, which does not attenuate, or using direct beam transmission like laser beams or microwave transmission, which are point-to-point transmission. They don't spread and weaken. They communicate directly to each other. These are the various technologies which are used for minimizing attenuation.
Yeah, thank you so much. That was very interesting.
Thank you. Those were both excellent questions.
Just have one request. Children, please ask one question at a time so everybody gets a turn. And after that, it will come back to you again if we have time. Okay?
Then ask. Say good evening.
Good evening, sir.
Good evening.
Sir, I have a question.
Go ahead.
Go ahead.
Mercury and Venus are not having moon,
Why?
but other planets are having moon. But
Yes.
why Mercury and Venus are not having moon?
Yes. The real answer is more complicated than what I am going to explain. But the simple answer is Mercury, as Mercury and Venus were formed, they, on one hand, they are small planets. Venus is a small planet, Mercury is even smaller. And their gravitational attraction was not sufficient to capture a satellite and have a moon. Moon is a natural satellite, so it was impossible, or it was difficult for them to capture because their gravitational attraction is smaller. They are small planets, and therefore they could not hold on to satellites, artificial satellites, natural satellites or moons. Earth managed to have one. Fortunately, we have a natural satellite, our own moon. But if you look at other planets, they are all giant planets. Jupiter, Saturn, etc. are giant planets. Their gravitational attraction is very strong, and therefore they manage to capture and keep satellites, natural satellites around them.
Did you understand, Janvi? You want me
Yeah,
to
ma'am.
translate? Good.
Thanks, sir.
Please tell me if you do not understand. I can try to explain again. But if you understood it, very good.
Yes, sir, I understood.
Thank you.
Welcome, sir.
Hi, Uncle.
Hello.
Can you hear me?
Yes, very well.
My name is Lisa Maria Matthews. I am from Cochin. I want to ask you the first question.
Go ahead.
How far is the star? I really want to know. Like in kilometers.
Which star are you talking about? Sun or other stars?
The other stars.
Okay, good.
Like in kilometers in the earth.
Yes, kilometers. Kilometer is a very small distance. So let me try to explain in two ways. Okay, let me try to answer this question in two ways. Suppose I take my, I stretch my arm like this. Can you, I stretch my arm fully out. Okay. And then I think my head is the sun. Okay. And I put Earth at the tip of my arm. Is that clear to you?
Yes, it's clear to me.
Yeah.
I want to.
No, let me fully explain. I extend my arm. I think that the sun is at my head and Earth is at the tip of my arm. If that is the situation, and if I want to put the nearest star, I will have to go about 150 kilometers away.
Okay.
Did you understand that?
Yes.
If I put Earth at an arm's length, about 1 meter away from the sun, then the nearest star will be about 100 kilometers or 150 kilometers away. It's very, very far.
Okay.
You understood?
Yeah.
Okay, maybe let me explain it. Let me also explain it in another way. Suppose you are walking, okay? If you're walking in a in a natural way, do you know how much time it will take to walk 1 kilometer? Roughly.
Is it 20?
Yeah, that is very
20
correct.
months?
No, walking 1 kilometer. You are going from
20
your house,
minutes?
20 minutes. Okay, 15, 20 minutes. It will take to walk 1 kilometer. Okay. So our walking speed is cover about 1 kilometer in 20 minutes. Okay. But light travels 3 lakh kilometers. 3 lakh kilometers in 1 second.
Okay.
You know, 3 lakh is a very large number, right?
Super fast.
Super fast. So 3 lakh kilometers in 1 second. Now, if you travel at that speed, it will take 4 years to reach the nearest star.
Okay.
So if you travel at the super speed of light and keep going, you will have to travel for 4 years to reach the nearest star.
Okay.
All the other stars are even farther away. Okay.
Okay.
Did you understand?
Thank you.
Yeah.
I have one more question.
Yes, someone said ask only one question at a time.
Again, later again, Lisa. Okay.
I will.
We have 9 more hands up. So after that, again, your turn will come. Okay.
Yes. Thank you, Uncle.
Welcome.
Welcome.
Hello, sir.
Hello.
I am Vriti Jain from Karnataka.
Mm-hmm.
I have a question for you. My question is how the satellite can connect the internet to mobile? How it is possible?
Internet to?
Mobile or TV, smartphones like.
Yes. So satellite is only a it's a intermediate station to which you send signals. So whenever you connect to the internet, whatever you type on your keyboard or the messages you want to send from your mobile phone, that information is transmitted through the mobile towers to probably the satellite, and from the satellite it probably goes to another satellite, and from that satellite comes down to wherever it is supposed to receive, if it is in the US, Europe, in Australia, and from there through towers it transmits back and forth again and again and comes to the mobile phone. So it makes many steps, goes from your phone to the nearest tower, then to the satellite, and back down to the towers, and then back to your mobile phone. So it is a many steps. And this way, satellite is just providing only a connecting link for the information to travel. It is instead of your phone directly communicating to another phone, which would be very difficult unless the phones are very close together, like a walkie-talkie. If you have a walkie-talkie, have you seen a walkie-talkie? Have you used a walkie-talkie?
No, I have seen it.
You have seen it. Okay, so walkie-talkie can talk to each other only within a certain distance, maybe 1 kilometer, 2 kilometers. After that, they cannot reach each other's signal. So if the signal has to be sent very far away, they will be sent to the nearest tower, from the tower to the satellite to maybe another satellite, and to the tower at the new place, wherever you're communicating to. and from there to the mobile phone, etc. So it's an interconnecting link.
Okay. There are many steps to satellite to send a message or a phone call, but also that
all
is
the
fast.
information, yes, all the
But
information.
also that is very fast.
Exactly. It happened very, very fast. For example, I am sitting here in Pune. You are sitting in Bangalore. And we can talk to each other because the information, my audio, my video, all that is being sent either through optical fibers or through satellites to a station in Bangalore, and then from there to the mobile towers in Bangalore, and then finally to your computer or your mobile phone, etc.
Okay, thank you, sir.
Thank you.
Good evening, Uncle.
Good evening.
My name is Aditya. I have a question for you. Can you go near the sun by rocket?
Yes, you can, except that it is very, very hot there. So if you if you go there in a rocket, you will burn. It will be very, very hot there. But people have sent artificial satellites to the sun. For example, there is a satellite, there is a probe to the sun called Parker probe, which was launched by NASA in the US sometime back. And that Parker probe has reached the sun, and it is collecting information from the space near the sun and transmitting back to Earth. So you can, in principle, go to the sun, provided you can survive the very, very, very high temperatures.
Okay.
Thank
you.
Hello, sir.
Welcome.
My name is Muhammad Sufyan. I want to ask you a question.
Please go ahead.
Sir, for how will the star look from here?
How will the
Star looks from here.
you have the stars? If you look at the sky in the night, they are very, very, very far away. So in the sky, they appear like dots of light.
Yes,
just
sir.
points of light in the sky.
Sir.
So you have you see many points of light in the sky, because they are very far away. You cannot see any of the the details. The sun is very close, so you can see the sun as a very large object in the sky. But other than sun, all the stars you see in the night appear like very dots or points in the sky.
Thank you, sir.
Okay.
Hello, sir. I am Medhini. I have a question for you.
Go ahead.
Where is the sky?
Where is the sky?
Means in some videos I watched, the sky is on the earth. Means it's very far to that I watched, but on the means sky is where means where is that sky? We can see the sky.
Yes. So what you think when you think of the sky, although it appears like an object, it is really not an object. It is just the empty space, or the space which you see around you as the sky. So when you see all the stars, they are at various distances, very, very far away. And therefore, they appear to be on a surface we call the sky, but there is no object called a sky. It is just a way we feel that there is something there, but it is really not an object.
Okay.
Okay, so but the distances we are talking about, as I explained for a previous question, the distances to these stars are very, very, very large. As I said, it will take several years or several hundreds of years if you have to travel to those stars, even at the speed of light, even if you travel at the speed of light very fast. But all that objects up there in space appear to you as if it is all on a surface like which looks like the sky, but there is no such surface. There's no such object.
Okay, sir.
Okay, is that clear?
Yes, sir.
Okay. Is there another question? I see a number of hands, but I can't hear any question. Is Hansika next?
Go ahead and turn to unmute. Yeah, 1 second.
Sure.
Anita, you're unmuted.
Yes. Good evening, sir.
Good evening.
My name is Anita.
Mm-hmm.
Sir, I have a question. Sir, where is the sun living, sir?
Where is the
Sun lives.
sun? Where is the sun? Sun is quite far away, fortunately.
Okay.
Very, very far away. It is about, let me see how to put it. So it is about 150 million kilometers away.
Oh, okay, sir.
Do you know million?
Yes, sir.
How many zeros are there in a million? One followed by
What,
6.
sir?
Do you know how much is a million?
I don't know, sir.
Okay, 1 followed by 6 zeros.
Okay, sir.
That is 1 million. Now you have to go 150 million kilometers to reach the sun.
Oh, okay, sir.
So very far.
Okay, sir. Thank you, sir.
You're welcome.
Sir, there is a question from Karnavidya Foundation. He's asking, I would like to travel to space by a space shuttle. I am a person with total blindness. Will it be possible? Please guide. Question from Chinnakarpa Swami, who is from Karnavidya Foundation.
Sure, why not? There is no restriction or limitation on who or who will not be able to travel. The travel will require more of being physically fit, because the travel is going to be very, strenuous. The rocket is it's not like traveling in an airplane or a train or a car. It is a very tough ride, So you need to be very physically fit. You will need to get a lot of training to withstand all that tough conditions of traveling to space. But other than those physical requirements in terms of physically fit, in good health, and so on, there is absolutely no restriction on, even if you are if you cannot visually see, there is no problem. I mean, you should be able to fly. There's no limitation on that.
Hope you got the answer, Karna Vidya Foundation.
Yes, continue to raise his hand. Probably we can unmute.
Yes, so India is planning its first Gaganyaan mission. We will try to put a person in space for the first time ourselves. And I'm sure in future, there will be opportunities for many of those young people like you to travel to space. So look forward to it. Who is speaking? Nirav, you are muted if you are speaking.
Hello, sir.
Hello.
So I saw a movie called First Man.
Mm-hmm.
It was about Neil Armstrong and his team going to landing on the moon.
Mm-hmm.
I wanted to ask that after so many years, why did nobody land on the moon yet?
Yes. So first of all, it is very risky to go there. So if you allow people to travel to moon, you have to make sure that they will be able to come back. And the travel is very risky. So after a number of trips to the moon, number of trips to the space, it was decided that the risks are so high that our technology is not yet, reliable enough to send people to the moon and bring them back. It's just a question of it being very risky and very expensive. But people are beginning to think of doing it again. Now the technology is much better than what it was in the 60s, 1960s, 1970s. The technology is much better now. We have better rockets. We have better spacesuits. We have better information about moon. We have better information about space. So because of all this, people are again thinking of traveling back to moon, going physically there and people there. But it was stopped in between only because it was very risky and very expensive.
Thank you, sir.
Welcome.
Satvik ask. Say hello.
Hi, uncle.
Hello.
My name is Satvik.
Hello, Satvik.
Ask.
Can I ask you a question? You can answer. Star is a different shape. Sun is a different shape. Both are stars. Why? Sun is a big goes more.
Yes, so sun appears to be big to us because it is very close compared to other stars. As I said earlier, the distance to sun is only 150 million kilometers. So if you travel at the speed of light, it will take only 8 minutes to go to the sun. So in that sense, it is very close. But if you travel at the speed of light to the nearest star, it is going to take 4 years. So 8 minutes distance at the speed of light versus 4 years. Compared to that, 4 years it will take to the nearest star. So although those stars are very large as sun or even larger than sun, they are very far away and therefore they appear like points.
Yes.
No, he actually asked the star shape is like this one. Sun is like a round. So he's asking, but sun is also called as a star. Why?
Yeah, so sun, it just so happens that the sun is our star and we are very close to it. So it is appearing like a sphere. Other stars are very, very far away. They will also have planets around it. And if people are living on those planets, they will see that star as a circle or a sphere because they are very close.
Okay.
The sun happens to be very close to us, and we are seeing it as a big sphere in the sky. Like the moon also is a big sphere in the sky. They're relatively close to us. The other stars are so far away that from Earth, they appear like a point in the sky. But the planets around those stars, if there are human beings or other kind of living beings on those planets, their sun will appear for them as a very spherical thing, but they will see our sun as a point in the sky. It is just very far. That's all.
Okay. Thank you.
Thank you, sir.
You're welcome.
Hello, sir.
Go ahead.
Hello. Yeah. My question is, sir, the sun has a gravitational force. It keeps aligned all the planets, but why do the meteoroids keep crashing over planets and their moons?
Yes, that's a good question. So all the planets, all the objects, every object has gravitational force. So you, for example, Ayan, right? Ayan is your name?
Yes, sir.
Ayan, you also have gravitational force. But it's very weak. It is a very small force. So sun has gravitational force, Earth has gravitational force, moon has gravitational force. All the meteoroids, asteroids, they all have gravitational force. And they are going around in the solar system. All of them are going around in the solar system, controlled by the gravitational force. Okay, the gravitational force of sun is attracting Earth and all the other planets, meteorites, satellites, and similarly the other way around. So they are all attracting each other. And because of this mutual attraction, they go around each other. Okay, it's continuously happening. So even the meteorites, comets, asteroids, they are also going around the sun. What happens is sometimes the path of a meteorite crosses the path of Earth. Earth is going around the sun.
Yes, sir.
Meteorite is also going around the sun, and sometimes their path cross each other.
Yes, sir.
And if it happens to be at the same time, the path is crossing each other, the meteorite will come and crash on Earth.
Yes, sir.
Right. So it is just a chance. They are all going around the sun,
Yes, sir.
except that their paths may cross, and if they cross each other at the same time, then they can hit into each other. Is that clear?
Yes, sir. So
Okay.
related question, same as the meteoroids when crashed on moon, and if there's any spaceship or astronauts over there, does it hurt them?
Oh, it will. These meteorites are traveling at very, very high speeds, maybe several kilometers every second.
So
And they are
yeah. Yes.
they are large rocks. So if they hit a place on the moon where there are our equipment or our people, it will harm them.
So then
That
how
is-
to prevent this?
You may need to make protective structures. It is a chance, first of all. The chance of hitting is small, so you can survive. But as more and more equipment go to the moon, more and more people travel to the moon, this will become a very high risk, and you will need to have protective structures to prevent it from directly hitting you.
Yes.
Or the other way around is you may keep watching the sky, and if a meteorite appears to be coming towards where you are on the surface of the moon, maybe you can launch a rocket and divert the meteorite away, hit it and
Yes, sir. So
push
this
it
work
away.
done by what are the profession who do this work?
What profession? Nobody is doing this work right now. It is all for future.
Yes,
So
sir.
you need to either become a engineer with an interest in space technologies.
Aeronautic engineering.
Aeronautics is also good. It is a good starting point. There are also, you can start with aeronautics, you can start with regular electronics or mechanical. See, these technologies require expertise in many fields: mechanical engineering, fluid dynamics, mathematics, even other areas like material properties. You require expertise in a large number of fields. So independent of which area you get your degree in or which you study, you can apply that in space technology, because space technology requires expertise in many fields, not just one field. Okay, you need expertise, people who are expert in communication. You need people who are experts in fluid dynamics, aerodynamics, aeronautics, mechanical engineering, every field, mathematics. So you have applications of all this in space technology. So you just need to be a good student. You need to understand. You need to learn well, study well, and then you can apply it to space technology.
Okay. Thank you.
Welcome.
Good evening, sir.
Good evening.
I'm Yukta.
Mm-hmm.
I have one small question.
Go ahead.
What is satellite?
What is a satellite? Is that the question?
What, sir?
Can you repeat the question?
What is the satellite? What is
Yes.
artificial satellite?
Yes. So the artificial satellites are objects we send from ground to space. Human-made objects we send on rockets into space are called artificial satellites. But there are also natural satellites, like the moon is our satellite. It's a natural satellite. Planets like Jupiter, Saturn, Uranus, etc. have their own satellites. And Jupiter has many satellites. We have only one natural satellite, but Jupiter has many satellites. Saturn also has many satellites. Satellites are objects which go around planets. It could be either artificial, made by human beings and launched into space, or there could be natural, like the moon.
Okay, thank you, sir.
Thank you. Welcome.
Sutan, go ahead.
Sir, I'm student, sir.
Hello.
Sir, I'm student, sir.
Yes, I can hear you, Susan.
Sir, is there any jobs for the visually impaired in space research centers? If so, what we have to learn for that, sir?
Yes, so it's an excellent question. Very good question. There are all kinds of jobs in space related or astronomy related areas, which people with visual difficulties can contribute to many possibilities. there might be some extra efforts that is to be needed to be put in place to make sure that those contributions can be made relatively easy, but there are all kinds of possibilities. There is no limitation. Now, what do you need to do? That's an interesting question. You, as I said in one of the previous questions, you need to be very good in whatever area you work, either in engineering subjects or in physics or mathematics, chemistry, whichever area, biology even, any of these science or engineering subjects and maths, you want to you pick what you like, but you do very well. You do extremely well. Whichever you like to do, you do it. You study that subject, but you have to do it very well. As long as you are doing it very well, you understand the subject very well, and you do, then you can contribute to space technology, astronomy. It doesn't matter. So your visual limitation is not deterrent. And of course, you have to make some arrangements for it, but it should not be a deterrent. There's many ways in which you can contribute. Welcome. Hello, Ansika.
My question is, why we do not feel the moment or
Can you please repeat the question after you're feeling better? Maybe you should drink some water.
Yeah, drink water and come back, Ansika. Okay?
Are you
No
okay
problem,
now?
we'll wait.
So if you want to ask now, you can ask, or drink some
Yeah,
water and
you
come
drink
back.
water and come. By then we will have the next question.
Yeah, Sagan Lal Jain.
Oh, that's Shruti.
Oh, sorry. Priti will just see who else is there.
You give other to ask the question. Okay.
So, we have a question again from Karna Vidya person. What will happen if I start walking straight from the shore into the sea? Where will I land? Will I land? Will I be able to go to the other side of the shore? Is the question.
Of course, if you can walk over water, that will be difficult. But if you learn how to walk over water, so when you say I
If
want
he
to
goes
walk
all along the side of the shore, where does he land? Is the question.
all along the shore.
Yeah.
Yes. So you would need to look at a globe of the Earth, a globe which depicts Earth, to know, depending on which shore you start walking from, depends on, you may reach at a different place. I mean, the shore is, so the surface of the Earth is made of all the oceans and the land masses. And if you walk along the edge of one landmass, you will keep going till it hits some other landmass or end up in another ocean. Where you exactly reach depending on where you start from, in which direction you move. So there is no single answer for that question. But to understand it better, maybe you should get a globe which has all the features on Earth, all the land, ocean, etc. shown there, and you start from one point and just walk down one shore, you will see where you will reach. So if you start from Mumbai and walk south or travel south along the shore, you will reach Kanyakumari. Or if you start from New York and walk south, in principle, you can walk all along the coast of America and then come down to South America and then walk along the shore of South America and go to Antarctica. So depending on which shore you are walking across and what that landmass is connected to, you will reach different place. You walk along the shore.
So CK, you can plan a world tour.
Yeah, it will be a very, very long walk, but it will be very interesting. And you should be prepared to walk on, or the shore may not be always walkable. There might be mountains and forests and all that. So it will be a very adventurous trip.
Yeah, he says thanks a lot once again.
Welcome.
Say good evening once again.
Good evening, sir.
Good evening.
Sir, I have another question. There are many stars like sun.
Yes.
Do they also having planets, their own planets, like sun is having planets?
Yes, yes. Almost all stars will have planets.
What about lives on other planets like Earth?
We think that the chances of finding life in some of these other planets, the planets around other stars,
yes,
there is very high chance of life existing there. We don't know whether it will be life like ours, what we see on Earth, maybe same kind of life, or it could be very different kind of life. But it is almost certain, almost sure that some of the planets will have some life or that. There is a lot of effort being made to look for life on other planets, but we have not found any so far. Many astronomers are trying to find life on other planets, but no success so far. But it's surely out there. It's there.
sir.
Hello, Ansika.
Hi, Uncle. I am Ansika. My question is, why we do not feel the movement of Earth
Around the sun?
Yes.
Yes, excellent question. Very nice question. That is because.
Welcome.
Yes.
Thank you.
That is because we are sitting on the Earth and traveling around the sun with the Earth, along with its atmosphere, everything. We are traveling together around the sun. So we don't feel like we are traveling because there is no, the speed is not increasing or decreasing. See, for example, if you are traveling in an airplane, you will feel that you are moving only when the airplane is taking off or landing, when its speed is changing. If the airplane is just flying through the sky, where the speed is not changing at all, it's smoothly flying in the sky, you will not feel that you are traveling. Similarly, since the Earth is flying around the sun or moving around the sun smoothly without changing its speed, we don't feel it. We feel movement only when the speed changes. So if you are traveling in an auto rickshaw, the speed continuously changes. It is going up and down. It is falling into some gutter on the road. It is bumps on the road, going up, going down. So as the speed changes, you will feel the movement. But if the speed does not change, you will not feel movement. And that is, for example, in the case of an airplane, when you travel by plane, you do not feel that it is moving unless when it is landing, when it's slowing down, or when it's climbing up in the sky. So when the speeds change. So change of speed is what is required for us to feel movement. The speed does not change, we will not feel movement.
Okay, thank you, Uncle.
You're welcome, Ansika.
Vritti, you can unmute.
This is the last question for the day. You've taken a lot of time of Ram Uncle already.
No worries. I'm happy to answer questions. You decide the schedule.
I have another question for you.
Okay.
Nowadays, laser operations are taking place.
Mm-hmm.
How it is possible without any problem to eyes or without touching inside the eyes? How it is possible for the eyes? Like
Yes. So we need to be very, very careful when you are using laser for applications. If you are not careful, the laser can create all kinds of damage, not just to your eye. Some laser can be very hot. It can burn your skin, burn your flesh if it is very hot. There are lasers which are used to cut metal. So if you have a piece of metal, you apply a laser to cut metal. So it can be that powerful. So when you are using laser, you have to be very careful. You have to put all kinds of protective equipment, either some protective suit, if your eyeglasses which protect your eye from laser, maybe even protect your skin from, for example, if you are using ultraviolet lasers, ultraviolet laser can cause cancer on your skin. You have to wear protection on your skin. So while you're using laser for various applications, you have to be very careful and protect yourself with appropriate. Yeah.
thank you, sir.
Yukta?
Thanks so much, Ram Uncle. Now I know how planets move around the sun.
Okay. Okay, Yukta.
They're talking of motions. Do you know there's so many types of motion? Neera will show us.
Sorry, I didn't.
Before we move to Neera's video, we wanted to express our thanks to Ram Uncle. We all enjoyed a wonderful conversation with the children and you. In fact, we learned a lot of things. and it's just going. We have a number of questions there, and we know that we're short of time. Probably we will have Ram uncle once again with us, and I think children have more questions and more valid things than what we do. I just felt that, I've not explored much of the world having my side. And I think having Ram uncle, the children will explore more. So thanks for a patient hearing and a wonderful, clear explanation. Going back to the age of their each child, you could explain it so clearly. And we have a lot of other adults also thanking for your explanation and making us wise today. Thanks a ton, sir.
Thank you. Thank you very much for giving me this opportunity to interact with the children and even clarify my own thinking about some of these questions, make you think how to answer them and how exactly it happens. So thank you very much, and I will be happy to interact with the children again.
Yeah, thank you so much. One last question from Giri before we can say bye to you, sir.
Sure.
Yeah, Giri, you can unmute and ask a question.
Good evening, sir.
Good evening.
My name is B. Giri.
Hello, Giri.
I have one small question, sir.
Go ahead.
The question is, what is the meaning of umbrella plant?
What is the meaning of?
Umbrella plant.
I did not get the word.
Umbrella.
Okay, umbrella.
Umbrella plant.
Umbrella plan.
Yes, sir.
Now, this last question is the one which has really trumped me. I will be honest here. I do not know what is an umbrella plan. I will have to look up that somewhere. I have not heard about that either in the context of astronomy or space or in general in physics. But I'm sure it means something. You have heard about it. I'm sure it means something. So it's just that I don't know. I don't know. Sorry.
Giri, we will figure out what it is and let you know, Giri. Okay?
Okay, miss.
Thank you.
Okay, you need one question, at least one question which you cannot answer, right? So, thank you for that.
I'm so sorry for putting you on the spot.
No.
I think he meant plan. I'm not too sure, but yeah, we will check that out.
Yes, yes.
Thank you so much, sir.
Thank you. Bye-bye.
We're honored to have you here.
It's my pleasure.
Thank you.
Thank you.
Yeah, Sufyan, you can go ahead.
Talking of motion, do you know there's so many types of motion? Dira will show us.
The blood circulates throughout our body and supplying nutrients to our cells. Our Earth goes around the sun and rotates around its axis, causing the cycle of day and night. One thing that is constant in life and universe is motion. Motion is defined as the change of position of an object with respect to time. Motion is the very essence of life, right to the basic building block, atoms. The electrons in an atom are in a constant state of motion. Motion is defined in terms of displacement, distance, speed, and time. For example, a car is moving in a straight line. When the aeroplane goes on the runway, it goes in a straight line. It is called rectilinear motion. And when it takes off in a curved path. It is called curvilinear motion. This slide is an example for linear motion. I am going in a straight line. Playing cricket, I am throwing the ball. The ball is moving in a curved path. This is an example for curvilinear. Movement that occurs when an object moves around its axis. The earth is moving around its own axis. The blades of the fan are moving around its central axis. I also have a fidget spinner that is moving in its around its central axis. For rotatory motion are the merry-go-round is moving in its rotatory movement. Another example of the rotatory motion is the chair, the exercise chair in the park. It is moving in a fixed point. When we sit on a swing, we move back and forth. This movement is called oscillatory movement. The swing is moving back and forth. The few examples of oscillatory motion are the hanging monkey is moving to and fro. Examples for oscillatory motion are the exercise machine in the park, which is moving to and fro. When the oscillation is rapid, it is called vibratory motion. I have a rubber band which is vibrating rapidly. This is called vibratory motion. One last thing, motion is always relative. So when you and your friends travel in a train, both of you think you are at rest and the train is moving, right? But for a person looking at the train from outside, it looks like both of you are moving. When we sit in a chair and think, now, I am at rest, are you? Think again. Actually, you are moving along with the earth at a very high speed. So friends, motion is the fundamental part of physics and is rightly said, movement is life.
Yes, you.
That's all for today. Time for feedback and questions.
Do we have any questions for our presenters? I think some of them had questions about audio description project of Sagarika. Right, Sagarika, you there? Vritti, you have a question. Okay, can you unmute Vritti, please?
I want to know about the Sagarika's and team's audio description. What you told.
Yeah, Sagarika will be joining in a minute.
Ma'am?
Sagarika will be joining in a minute.
Yeah, okay.
Meanwhile, let's take Medini's question.
Ma'am, I have a question for Pranavana. Ma'am, how he makes some sounds in computer?
Pranav, you're there? Pranav is there, yeah.
Hi, sorry, apparently my microphone was switched off. Hi, what's your name? May I know your name?
Have you made some? Hi, I am Medini. Have you made some sounds in computer?
Hi, Medini. So basically, here's what I did. Okay, there is an app on the computer which is called Audio Graphing Calculator. Okay, it's a basic app that you can run, and what it does is you give it some data. Okay, like a math sum, and then what it does is it will make the graph for me on the screen, and then it will play the graph. Okay, that's how I was making the sounds from my computer.
Oh.
Did you understand?
Yes.
Okay, cool.
Thank you.
No problem.
Any other question? Pranav has one.
Hi, sorry, I keep muting. I have a question for Kavya. I want to ask, can you guess, or do you happen to know just how small is, at the end you talked about the Core i7, right? Which is one of Intel's processors. Do you happen to know, or can you guess, just how small that processor is? Or what the size of it is? Just how small that processor is. Is she here? Oh yeah, she is.
Unmute Kavya, please. Yeah.
Can you hear me?
Yeah.
Yeah, Kavya, go ahead.
I'm not exactly sure, Pranav. That's a great question, by the way, but I'm not exactly sure. Honestly, I'm not really into this tech. I think it will be at least smaller than 2 inches.
Okay, I will tell you because I just Googled it after I asked you. I wanted to just sort of just ask you, because if you knew, you would be blown away. It is just 5 nanometers small. That's 0.0. It's basically smaller than. It's basically like 1/1000th of or 1 by 100,000 of a millimeter.
Whoa!
Or 5 by 100,000 of a millimeter.
That's crazy.
Yeah.
Wow.
Okay, now let's have Sagarika to answer Vritti's question.
Can you hear me, ma'am?
Yes, Vritti, we can hear you.
Can you see me? Yeah, my question is to Sagarika.
Okay.
She was describing about audio description with her team. What is that? I didn't understand. And she said she saw a movie with the audio description in Enable India. What is that? I didn't understand.
So audio description it's when you just describe whatever you see on the screen. That's you just describe what you can see. So I watched a movie and there was audio description. So whatever was on the screen was described.
Okay.
Can you give an example, Sagarika?
Okay, so in the movie, if there's a crow flying, I won't know that unless someone describes it by saying there is a crow flying.
Yeah. Audio will describe and tell us. The crow is flying. Like.
Yeah.
Okay, thank you.
And what do you do in your audio description project in the SIG? Do you also do some description for movies? What do you do, Sagarika? Sagarika, my question? Unmute.
Yeah, needs to unmute.
Okay, can you repeat the question?
So in your audio description project, do you all audio describe movies like the one that you watched in Enable India? What do you do?
No, we audio describe videos.
How do you do that when you can't see?
The other people in my group who are with me will audio describe, and I will ask them questions about the video or things I didn't understand, and they'll describe it.
Excellent. Are there any more questions? Giridhar had a question. Giridhar, do you have a question? You had raised your hand. Otherwise, I have a question for you, Giridhar.
Can you hear me?
Yeah.
Yeah. Yeah, I have a question for Pranav actually. So, hey Pranav, are you there?
He's there, Giridhar. Go ahead.
I'm very much here. Go ahead.
Oh, okay. Yeah. So here we meet again. So, yeah, I was really interested about the calculator, the graph calculator, which you're talking about. I mean, I really wish I had it during my engineering days to, to read graphs and all of that. So firstly, a great stuff, first of all. And I was wondering, suppose the graph is not continuous. Suppose, I mean, you did it for x square, x cube, and so on. So what if it is broken? So does it also, um, give out a sound for discontinuous graph signals? So that is what I just wanted to know.
Yes, it does. You can actually, as I said, plot the points for a graph manually, and it will actually play sounds. It sounds quite jerky, honestly, because it doesn't. When you plot points manually, as I showed, it doesn't actually play the sort of line that connects the points for some reason. But it will actually make you listen to it. And in fact, one thing that I didn't actually show because of time constraint was the fact that you can actually manually navigate through points with alt left and alt right arrows. So you can actually manually navigate through each and every point. And then there are cool features like finding intersections and zero crossings and all that. So
That's
yeah.
amazing. So I'll connect with you probably off the call so that we can explore together. So yeah.
Sure, no problem. Always willing to.
Medini, you have a question? Do you have a question?
Ma'am, I have a question for Sagarika. Ma'am, she's NVIDIA is very fast now. How she can understand what is that NVIDIA is telling?
I have practice since I've been using it for a long time, so I had practice.
But it's very fast. We can't understand that.
So I use it every day. So when you use it every day, you get used to it, and then you understand.
What is every day?
So I use my computer a lot, right? So I need NVDA for that. So I use it every day.
Thank you.
Okay, thank you. So, Giridhar, my question to you. So when we started thinking about having curious minds, some of the parents said we want to have a role model like how we had 2 years ago, and they were mentioning about you. So we thought, why not get you back again and listen to the continuation of the story. 2 years ago, you were a mechanical engineering student, and you explained about how you were, about your challenges and how you made things possible at the mechanical engineering front. So now I want to ask, what happened after that? Now you've graduated. So what happened next?
Okay. Yeah, so I had graduated in 2020. So after my graduation, I had spent some time.
Sorry, can you turn on your video? We want to see you.
Oh, okay. Just a minute. I'll just turn on the lights. Yeah, I hope you can see my video now.
Yes, we can see you. Go ahead.
Okay, yeah. So yeah, the question was, okay, what after my graduation? So after my graduation, I had actually spent a lot of time to search for the right kind of jobs, because during my education, it was mostly about understanding the concepts. But when you want to apply for a job, you need to showcase to the employer that how will you do the particular job. So I was actually exploring multiple ways to do that. And yeah, I did multiple courses, and I got a lot of certifications. So I probably spent 6 to 8 months to do this. And also because there was some hiring which had happened, and due to COVID which had come up in 2020, so it was dropped off, and a lot of job changes were happening. So I took this time to understand what are my strengths and where I can contribute the most. So during this time, I actually did some certifications on electric vehicles, batteries, and many other things. So yeah, so I basically spent a lot of time, and also had written an examination for IM, which is a fellowship exam, and I had cleared that particular exam as well. So I got an offer from them also. And yeah, and parallelly, I had applied for the current company which I'm working for. And yeah, I was selected for that particular role I had applied for.
So you had options, is it, to take up jobs? That's wonderful, yeah.
Yeah.
So how did you choose this one over the other?
Yeah, so basically, I was looking at opportunities, an opportunity which can give me chance to learn multiple domains. And yeah, so the company which I'm working for uh, gave me this opportunity to explore what I wanted to in terms of technology and in terms of mechanical engineering. And yeah, the main reason was they were willing to give me an opportunity in the domain which I studied, so mechanical engineering. And yeah, so the company was very positive, and I liked the company's culture and the way I was welcomed warmly. So I took in I took a chance to opt for the present company. But yeah, the other opportunity also was hard to leave, because that was a great opportunity to work with IIM Bangalore and the government of India under skill development ministry, and with the district collector directly all together. So that was a great opportunity as well. So it was a very hard choice to make. So, but because this was relevant to what I have studied and what I wanted to do and what I wanted to explore, so I took up this opportunity.
Wonderful. Look, now Ram uncle has told all the children that you have to be a mechanical engineer to go to learn about space. But that's an important thing to study. So I'm sure many of the kids would want to know from you how you did your mechanical engineering and what would be difficult when you are blind. So what is really not accessible? How did you make it possible? I know you've told this 2 years ago.
Yeah. Yeah, it will be a refreshment for me also. So anyway, see, mechanical engineering, to give a small background. So I did 2 years of my engineering with vision, with complete vision, and I lost my vision only after the second year of my engineering. So one thing was, I knew the concept when you say a particular thing. So suppose if you take a bracket, or if you say that what is a gear, what is a motor. So I had a vague picture of what each element is. So because I had the foundation, I just had to go deep into the details as to how things are working. So that was basically the intention for the third year and the fourth year. So it was relatively easier for me because I knew what the image was. And if you ask me what the challenge would be for a person who lost his or her vision slightly before, so the biggest challenge would be visualizing, because it's not the subject which is difficult. It's because the way that the syllabus is and the way that is teach is difficult. But having said that, when I was in my third year of my engineering, so I had actually converted all my textbooks into EPUB or an e-text format. So this made my reading easier. It can be reading diagrams, not reading exactly, image descriptions given to the photos and the formula. So if you take this particular format, you have an option to go word by word and sentence by sentence. And that had actually given me a lot of scope to understand the formulas and mathematics very easily. And the college had also given me a lot of models to feel, touch, and gave me time to explore the equipments in the lab. So that what I used to do is, after my lab hours, my professor used to take me around the equipment and teach me what each thing is, and he would tell me, you have to do this particular task to get this output. So this is how I actually learned. I completed my engineering with this particular aspect. So yeah, the main thing was even the graphs. If you take any kind of examination, you have to understand diagrams. So my mother and my friends, so they made some tactiles with threads, so on a sheet of paper. So I must have shown you 2 years back a sample of them. So, and also a 3D diagram of how each thing looks. So because I can feel the outline, and I can tell the scribe to draw the same in the examination hall. And yeah, again, with the practice, I used to practice those diagrams on sheet of paper, not exactly, but a rough sketch, just so that I can explain a rough sketch to my scribe during my examination.
Anybody else has questions for Giridhar or anybody? Giridhar Anna is totally blind or partially blind? Ma'am, Vritti is asking you.
Sorry, come again.
Vritti is asking, Giridhar Anna is totally blind or partially blind?
I'm totally blind now. Yeah, now I'm totally blind.
Can I ask a question to Giridhar? Savita here.
Hello.
Hi. So, Giridhar, this is a question that, I would want to ask after you went through the situation of getting blind.
Yeah.
So, was the initiative to learn, study, and all from your end, or was it that the help that you got motivated you to study?
I can say both because I'll give you why I want to do mechanical in the first place. So in my 10th standard, I actually used to watch a TV show where they used to modify cars and do a lot of stuff with even a lot of shows in aircrafts and how space works and all of that. So that is when I wanted to do engineering right from my 7th, 8th, or probably I think 9th and 10th standard. So yeah, so because I had this interest right from my school days, so I didn't want to let go of it very easily. So I wanted to give a try and explore how I can do it, because a lot of people told me why it can't be done, but there are very few people who told me how it can be possible. So yeah, I think it is actually an effort from both the support system and the interest I had in the subject. And because I had the interest in the subject, the college was they had told me that okay, we can permit you, and we can give you all the support you want. Yeah, so the first thing, the important thing is the motivation from self. And I was also fortunate to have a lot of people who wanted to support me. And because it was very tricky at that particular time, people started giving me ideas of how to probably how we can try and how we can make it possible. Yeah, so yeah, it was effort from both the sides actually.
Okay, thank you.
Hi, Giridhar. I
Hi.
think you are truly an inspiration. I heard you like 2 years back. Hearing you again, it's like really amazing. So I have one question for you.
Yeah.
How does a day in your work look like? What are the typical things that you do, and what are the challenges that you have actually? I mean,
Yeah, like any other challenge, the first challenge would be the accessibility. Suppose I know how to design a particular thing, and suppose the software is not giving me an opportunity to work with it. So that is the main issue with any kind of task. But yeah, I think most of the tools, the basic tools which I use so far are pretty much accessible, and whichever are not, we try to figure out ways to come up with alternative ways, or convert it into a different format to make my work easier.
okay.
I have a question for you, Anna.
Yes.
If you want to design something or some mechanic things,
Mhm.
all software is not accessible, then how do you do?
Yeah, that's a good question. So the design work which I get, so that is so I get the task which is possible for me to do. So wherever the tools are accessible for me, so that is where the design that is where people ask me to design. So whichever is not accessible, so for now we try to come up with other solutions. So maybe one tool is not accessible, but maybe you can make it accessible some other way. So that is how we actually approach the design.
Thank you,
I
Anna.
think, yeah, I think you have understood. So maybe if you want me to explain, I can
You
do
can,
it.
yeah.
Sorry.
Yeah, you should have explained, then I can understand easily.
Okay, yeah. Yeah, so suppose if I want to design a particular shape or particular so usually a design in our field, it's not only the shapes. So it can be it can be temperature, it can be any other thing. So yeah, so if you want to design a temperature, you need not actually be able to see what the temperature is and what is the calculation you have to do. So so all these tools, like what I think Sagarika or someone explained, the Excel sheets. So you can use that also to, make some calculations and come up with some design. So we actually work in team. So it's not like all the work I should only do it. So one person does one task and the other person does another task. So we actually share a lot of tasks together to complete one particular design. So that's why it is easier.
Okay, thank you, Anna.
There's a question from Anupam Agedar.
Okay.
How did you do the mathematics in your engineering course?
Yeah. So, like I said, I gave the book for my engineering books for conversion to Bookshare, and Bookshare had actually converted all the textbooks to a readable format. So there is this format called as EPUB. So you can use it with the help of screen reader, and it is compatible. So when the book is converted to that particular format, like I said before, the mathematical equations and expressions, you can read it word by word and sentence by sentence, and you can go it line by line. And the NVDA tool will also read out the symbols and names. So with the help of this particular tool, in conjunction with the converted textbook, I was able to read the mathematics. And yeah, similarly, I used to practice it in MS Word. So in MS Word, you can actually write formulas and you can write symbols, mathematical symbols. And yeah, sometimes I used to practice it, and sometimes I used to do it orally, because once I read, when I understand what the symbol says, so I can memorize and I can do the same calculations. I hope that answered the question.
I think so, yeah. Anupama, yes? Yeah, she says thank you. Any other questions? Otherwise, we are done for today. Thanks so much, Giridhar.
Thank you, ma'am. Thank you so much for the opportunity. Yeah.
Vritti, over to you.
Hi all, Vritti here. Thanks to wonderful audience, Ram Uncle, participating organizations, all the participants, their parents, and their teachers for their tremendous efforts to make this event possible online. Don't miss part 2 of this event tomorrow with facts of surprises. See you all tomorrow.
Bye, people. See you tomorrow. Bye, children.
Bye, ma'am. Bye, all.
Hope you enjoyed today.